Hey everybody, welcome. My name is Caleb, and this course will be about Oracle Database. So, if you don't know anything about Oracle Database, that's perfectly cool because we're going to explain it. This is a beginner style course. We're going to take it kind of slow, but we're also going to go in a lot of depth. If any of you have ever seen any of my other videos, you kind of know my style of teaching, so I'm going to keep it the same. Now, just to kind of start off, let me kind of explain. Oracle Database is a database, right? There's all kinds of different databases. You might have heard of MySQL, SQL Server, MongoDB. There's all kinds of different databases. The one we are going to be using, Oracle Database. Now, Oracle Database is known as an enterprise database, whereas MySQL is something, that's another database. That's open source. It's not an enterprise. They might have enterprise versions or something. But anyways, there are free versions, so that's probably what I'm going to be using. So feel free to join right in with that, because I know a lot of you don't want to pay for the software when you're just learning it or something like that. Yeah, so let's get started. If I already lost you on what I was talking about with databases, don't worry. Here's where it starts fresh, okay? So, what is a database? A database is designed, it's basically a program that's designed to store a bunch of information or data. So a database stores data. So data goes inside of the database, if that makes any sense. Well, what's data? Well, think of data very broadly. It's nothing too specific. It can be anything that you need to store for later use. For example, usually databases are used for businesses, so a business will need to store data so they can analyze that data and make business decisions, right? So if they're like it's a restaurant, right, and they're making two kinds of hamburgers. We got hamburger with extra tomatoes and then a hamburger with no tomatoes. I don't know, stupid example. But basically, they want to know which one sells better so they can advertise it on television or whatever they're advertising on. Well, then they can analyze that data and make a decision based upon that data. It's kind of like analytics or statistics. If basically like 80% of the people that come into the store buy the tomato hamburger, why would they advertise the one without the tomatoes when it's only a small fraction of their sales and no one values them? So they would choose the hamburger with the tomatoes, right? So that's an example. We could store the data in that situation would be the sales. And we would store information about those sales, such as when the sales occurred, how many, who bought it, what the price was, and so forth. And then we can put all that data together and get a final summation of what the sales are like, and you can make business decisions off of that data. Now that's just one use for a database. There's others. A very common use is for websites. They store all of your information in a database. Any kind of program or website that you put information in and it saves it and then you X out of it and then open it up at a later date, that is stored in something. 90% of the time, it's a database. You can store information in other things, such as a spreadsheet. There's comma-separated values. Just notepads. You could use a notepad. I made an application once where I had to take a URL, and I didn't want to create a whole database for it. So all I did was just make a little URL.txt or whatever, and then I just copied the first line of that, which had the URL in there. So if I needed to change the URL, I could just open that text file and change it. So that's an example of how I use Notepad. Comma separated value, that's pretty self-explanatory by the name. And a spreadsheet, well, spreadsheets are kind of like a very simplified version of databases. And you'll see why pretty soon. But I'm sure a lot of you have worked with spreadsheets. Spreadsheets have, like a table-like look with columns and rows. These are columns and this is a row. Well, a database is visually represented the same way. In a database, this would be known as a table. We got the columns this way and the rows this way. That's going a little, I just want to give you a taste of like what we'll be working with. But we're going to try and think of it a little more conceptually first, just so you guys can get a better idea of how we store data, what kind of data we want to store. So that way you don't get confused on if we should store it this way or that way or what. So let's try to do that now. So if you guys are wondering why you would want to use a database when you can use something like a spreadsheet or just a notepad or a comma separated value or anything like that, why would you want to use a database? Well, there are some really good reasons, but I also want you guys to understand there's not always a reason to use a database. For example, what I talked about earlier, how I made an application and I needed to pull a URL, that's the only thing I needed. So I can just make a text file 50 times easier in my opinion. So there's not always a really good reason to use a database, but oftentimes there are. If you have to analyze data, store a lot of information, and so forth, you might want to look into a database. By now. Right, so I'm just going to go over a couple of examples how a database is better than, for example, a spreadsheet. It's worse though because it's more complex, it's harder to learn, and you can mess things up if you don't know what you're doing. Whereas a spreadsheet, it's kind of like, grandma can do it, maybe. I don't know. So, what are the benefits of a database? Well, if you think of a spreadsheet, you have all or nothing. So, we got a spreadsheet here, right? We got our columns and our rows, and we can put information in that, right? Well, what if I want this row, this column right here, which has people's social security number, I want that to be completely private. I don't want no one to see it. And then I'm going to share it out to all my employees. Well, that's not really going to work out too well because the whole spreadsheet is a whole, right? Another issue, there's not good support for multiple people working on the spreadsheet at once. Now there are some solutions that help with that, such as Google Drive, where you can use spreadsheets with multiple people. But in general, databases can support multiple users with multiple different rules. So this person can do this with this information, but this person, he's not allowed to do that. That's off limits to him. So there's multiple different things you can do with the database, different rule sets. So you can set kind of like standards. All right, so like basic user, administrator, super administrator. You know what I mean? Whereas a spreadsheet, you're a little bit less flexible with that. Another good thing is like if you think of spreadsheets, you usually store all the information in one spreadsheet. So let's say we got people's information about themselves. So you got their name, their address, and their phone. But what if you only want the phone number and their name so you can go through and call them? Well, in a database, that's really easy. You can just select certain pieces of information. Whereas on a spreadsheet, we might have name, address, and phone. And if we wanted to take this address and hide it, that's not super easy. But with a database, that's a piece of cake. With the database, there's higher security. The data is protected better than a spreadsheet, and it's less likely to be hacked into or destroyed maliciously. So there's higher security. Also, on top of that, there's usually better recovery options if something was to go wrong, such as the power went out or your computer exploded. That's all I'm going to explain for this video. Next video, we'll be discussing basic design methods for databases, and then a few videos down the road, we're going to be installing Oracle database and showing you around a little bit on that. Then we'll teach up here, program on there. It's gonna be sweet. So be sure to subscribe. Also support me on Patreon. A Patreon place where you can support me month to month. I just got a patron for $10 a month, which is awesome. So Chad Leon, be sure to send me your shirt size, because you never did. So you want a shirt, but I have no idea what size you wear. But thank you. Alright, peace. Yeah,
Were you recording?
I was.
I'm so sorry. I gotta finish this. As soon as I turned it on, I thought, oh, give me a minute.
Hey, what's up guys? I've literally been making videos for like 10 minutes today, and I already started making one, and I forgot to press record. But luckily I got it this time, so. Hey. Okay, it's working. Sorry. So this video, we're gonna be talking about basic design methods, or starting information, whatever you wanna call it. We're gonna be talking about entities and attributes. These are very, very important in databases, and I highly recommend you really understand the fundamentals before you start diving into database programming. Now, database design is a huge concept. I actually have like 70 YouTube videos over the topic. A whole series over database design that's like 50 videos. So it can get very complex and in-depth, but you don't really need all of the information. You can start off with just a little bit of few things and start designing your own databases. And the best place to start ever is entities, attributes. Now if you think of an entity, you might think of some like mystical creature or something, I don't know. But just think of an entity as something. Let's use a blow-up mattress, for example. Alright, so I got a blow-up mattress. Alright, that's the blow-up mattress. Now this is an example of an entity. Let's just worry about entities. I'm going to get rid of attributes right now. There's two really classifications, right? We have generic and then specific. Generic and specific describe how specific we're being when we're talking about an air mattress, right? We could be talking about a very, very specific air mattress with a serial number of like 10125 or whatever. That is very specific because we're talking about a specific air mattress, right? We could also be very generic, and we could just be talking about air mattresses in general. So it doesn't really matter which air mattress. In fact, we could have multiple air mattresses. That one looks pretty hard. Got a saggy one, you know. There's all kinds of air mattresses. One for everybody's likings of air mattresses. This is very generic. This is generic because we're not being specific on this specific air mattress. We're not talking about one individual air mattress. So that's the difference between generic and specific. Generic is just a classification of something. Specific is a specific example of that something. Let's talk about puppies. Alright, so I got a puppy here. This puppy, his name is Swag Dog. Alright, answer the question. Is this specific or generic? 5, 4, 3, 2, 1. It is specific. That's because we're talking about a specific dog. Because his name is Swag Dog. Now what about this? Alright, here's another dog, which kind of looks like some weird puzzle piece with like a hand. I don't know. This is just dogs. We're using this picture to represent dogs in general. No specific kind, just dogs. Is that specific or generic? I hope you guys guessed that one. It's generic. So you got specific and generic. Let's move on to attributes, and then we'll discuss why all this is important. So let's move on to attributes. There's also generic and specific attributes. So what is an attribute? An attribute describes something. So a generic attribute describes a generic entity, such as dogs. A specific attribute describes a specific entity. Specific describes a specific entity. So generic, I got dogs. Specific, Swag Dog, which is a specific dog. Now, what do you mean by describe? I heard you say that. Heard you ask me that question earlier, so I'm going to answer that. What do you mean by describing a generic entity? Well, if you think of an attribute of somebody or something or a dog, it describes that thing. So I could be like, wow, this dog, swag dog. See how fast I can draw a dog? Boom, dog. This swag dog, let's describe him. Well, he's ugly. Sorry, buddy. And he's about 25 pounds. And he is lonely. Poor buddy. Alright. That is example of specific attributes. Now let's talk about generic attributes. We have a dog, alright? It doesn't really matter what kind of dog. Boom. This is just a classification of dogs in general. We're just using this picture to represent dogs. Let's describe the entities of dogs. They might have a name, their weight, maybe their height. Height? I don't know, it's for height. And their color. So these are generic attributes. They are basically groups of possibilities. Name, it could be swag dog, it could be puppy, it could be bubbles, it could be other weird names humans give dogs. Height, it could be 5 foot, 6 foot, 80 foot. You know, big dogs. I like big dogs. Color could be blue, green, rainbow, indigo, violet, charcoal, onyx, clear. Those are generic attribute groups. So let's kind of make a chart here. Just trying to make it clear in your mind. Gotta get my eraser. Let's give a generic, and then let's give a specific example matching that generic, which would be a specific. So don't get confused. Just follow me. Let's use humans, right? So we got person. Very generic. That's an entity. It's a type of entity. That's another way. Entity type. It's the person. Alright, the person has a name. You know, maybe a phone number if they're from the modern world. You know, they might have a height. Which I still not sure if I spelled that right, but height, they might have a height, they might have an age. No, even better, a birthday. And yeah, so forth. These are generic attribute, basically categories. Right now we have this person. Let's draw a picture just to represent him. He's flying through the sky with a cape. Alright. This guy's name is Superman. His phone number is 1-800 You wish. His height, probably like 7'11". Birthday, well, I don't know. So let's just go with like June 5th, 1938. This is generic. This is specific. That's important to know because when we design tables, which is what we store our information in, we want the titles of the columns and the table itself to be generic, but the values that we put into the table need to be specific. So if we have a table, we can make this, I don't know, customer, alright? I know, if you guys have ever seen my other videos, this is like the only example I ever use, but doesn't matter. Now we can also give these columns. So we could put, you know, Superman. So this is basically the same pattern we're going to do for every single table. Here we have the entity type. Here we have the specific entity. Here we have the attribute types. here we have specific attributes. Now if we wanted to add another person in here, we could. We could put Batman, blah, 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 blah. And then I can't think of anybody else. So yeah guys, hopefully that makes things clear. Entities, attributes, specific and generic. That's pretty important, so hopefully that was helpful, and hopefully it clears up how to make tables in the best possible way. Peace and subscribe! Welcome everybody. This video will be basically an introduction to Oracle database, how we can install it, and how we can connect to the database. So, if you've never done any database configuration or setting up, it can get pretty confusing at times, but I'm going to try to break it down so it's simple. So first, you'll need to get on a web browser, which is Google Chrome, and we're going to go to Oracle. And just go to oracle.com, and then what you can do at the top, you see downloads, hover over that, and find, there's two options here, Oracle Database 11G Express Edition. So the way it works on here is they have a primary edition that they sell, that's 12C, and then they have an Express edition that's 11G. So it's one number back, which means it doesn't have all of the features as the 12, which would be the most recent one, but it's Express, which means it's a smaller file size, it's for smaller applications, smaller purposes, but best of all, it is free. So this is the one we're going to be using. Now when you get to this page, there's a few things you're going to have to do. You're going to have to click Accept License Agreement, and by that I mean you have to read the entire thing. Oh, it's such a good read. I read it like every night. Alright. Then, what you're going to do is have to figure out which operating system you will be using this server on. Let's click this, and you'll have to probably sign in. As you can see, it's downloading for me, but that's because I'm already signed in. So you can see it's right here, Oracle XE. XE stands for Express Edition, which is the edition that we downloaded. So this is a zipped folder, as you can see in the little pop-up. Open it, and I'll just click extract all files, and my downloads are fine. That's a fine place to do it. So the downloads, and this is going to create a new folder with that name. Alright, here we are. So we can click this, and then there's this setup.exe. Click that. If a pop-up pops up, click yes. Alright, boom, there we go. It is ready to install. So let's just get rid of some of this other junk so it's not so cluttered. I'll probably need that later. I'll leave that open. Then click next. Make sure you read all that. Next. Looks good. Next. And we're going to make a password. This is going to be kind of like the administrator password, so it's like the main account. That account name is actually known as system. See, as you can see here, system. Something simple. If you want to follow along, you can put that, or you can use whatever you like. Install. Alright, now it's, creating and starting service. Oh, wow, that was fast. Okay. Okay, it just finished, so you can click finish on that. Now, after this, you might be wondering, how do I run the thing? Well, let me show you. Click the start menu, and click all programs. You can look for something gold, or find Oracle Database 11G Express Edition. When you click that, it's going to open up a bunch of different options. Sorry, I'm eating an apple. The first thing you're going to want to click is Start Database. You're going to get this little command prompt thing. Okay, great. Then you can just lower that and go back to the same place. And you're going to click Run SQL command line. If you're a beginner, you might not know what SQL means. Let me explain. SQL stands for Structured Query Language. It's basically the standard language we use to communicate with databases. It's kind of like how we tell people to do something in English, well, we tell the database to do something in SQL. So yeah, that's pretty simple. Now this is where we actually use the database, and I know it doesn't look real pretty, but I'll teach you a cool solution in just a minute to make it more friendly. Alright, one more thing. If you go to All Programs, click this again, you can click Get Started. That's going to bring up a web page, right? And you can see it says 127.0.0.1. That's a loopback address, which is basically on your home computer. Then it says 8080. That's the port. If you have something such as Skype running or XAMPP, that might cause issues, and this might not work out right. So if that's the case, you'll need to disable those. Now this is where you can do some extra configuring of your database, but we're not going to get into super much details with all this right now, so we'll worry about that later. Just wanted to show you that. Alright, then one other thing, if you go back, click this, you can click Get Help, and then you can click Read Documentation. This is where you get the official documentation for the database, and it'll talk about everything you really need to know. So there's all kinds of information here. You can search and so forth. So if you needed help installing, you could click right here, and yeah, that's basically it. Now we can sign in to our account we created by saying connect, and then it asks for your username, and it's going to be system. The password, whatever you put in, mine was pass, and it doesn't show up. And press enter, and it says connected. Now you can start doing commands that are part of the SQL language, but we'll get into that later because I just want to show you how to set everything up in this video. So let's move on to one other thing I wanted to show you guys. Go to oracle.com, or I think it's .com, yeah, and then go to downloads and SQL developer. And then if you don't have the JDK, which stands for Java Development Kit, you are going to want to download that with the JDK. So I'm on Windows 64-bit and I'll need the JDK, so I'm going to download that. And I already have it downloaded, so I'm going to actually cancel that. So you run it, and once again you have to extract it, that's fine. Alright, it just finished, so you want to open this. And they're going to find sqldeveloper.exe. And yes. Alright, so would you like to import preferences from a previous, no. That's if you have a previous edition of this and you want to import data from that one, well then go right ahead, but I don't know why you'd be watching this tutorial if you already know what you're doing, so. Okay. So this is the main page. No! Alright, this is the main page, right? Now, I suggest before you start anything, go to Tools, Preferences, and then Database, and then Worksheet. These are just a ton of settings. This is just one that I think is useful. Grid in checkerboard or zebra pattern. That makes every other line of code a little darker background, so it's really easy to follow lines across rather than just being white text, black text on a white background, I mean. Now we can put a default path for scripts if we want, so we can browse, and I'll just put mine in my documents, create a new folder, and just name it whatever you want. Press OK. Alright, so now we need to connect to a database. By the way, the thing we're running right now is to make the database a little more user-friendly than just this. So that's what the purpose of this is. So we need to connect to a database by pressing that little plus. Just click it, and this will come up. You can name it whatever you want. Username, that would be system, password, pass. Localhost 1521 XE, looks good, and then you can click connect. Alright, and there we have it. You can see it right there, and if you give it just a minute, it will open. So we officially we've completed our task of setting up the server and connecting it with Oracle SQL Developer, and that gives us the ability to start running queries on this database, which is basically running commands and doing more things. I wanted to teach this early on in the series, so those of you guys who like to tinker around with things, you could start getting used to the layouts and the buttons and typing things out on your own rather than just writing it out on paper. If I teach, you know what I mean. And I'll be going back and forth from the chalkboard to this, and we'll be learning both concepts and practical code. So thank you guys, and be sure to subscribe. Be sure to subscribe and support me on Patreon. Thank you, and goodbye. Welcome everybody. How do I start this, Aaron? I don't ever know.
Had an issue with it.
Hello everybody, welcome back to your 4th Oracle SQL tutorial, right? This video and the next videos I like to call the 5 video database design primer, right? So I'm going to take basically my 50-part database design series, get rid of all the useless junk in it, and then I'm going to condense it down into like a 5 video power database design series within this series. So this video and the next 4 videos are all going to be database design relating to Oracle database. So get your pull-ups because you guys are big kids now. We're going to get started right now. This video is going to be vocabulary, so we're going to start off with SQL, Structured Query Language. This is the language that we use to communicate with the Oracle database. Right, so to illustrate this, we have us, these stupid little people here, that don't know anything about how computers work. Well, at least I don't. And then we have the database over here, right? And we communicate with this database using SQL. That SQL is able to be understood by humans. It makes sense. And the computer or the database can take that SQL and then convert it into machine code. By machine code, it's just lower level code that actually tells the computer to do things like retrieve files. We don't have to do any of this because SQL is able to do that for us because the database understands SQL and we understand SQL. So we talk in SQL to talk to the database to talk machine code to do the complicated stuff. Another thing about SQL is it's actually a standard language. So if you go from Oracle database over to MySQL, you probably notice that this also has SQL. That's because SQL is used for every single kind of relational database management system. You're probably wondering, what's a relational database management system? I'm gonna tell you. So a relational database management system is basically a really fancy word to mean the database. We talk specifically using SQL to the relational database management system. So Oracle database is an example of a relational database management system. If you're thinking what I'm thinking, you're probably wondering what in the world relational means, right? And if you've ever done research on this, you'll get a lot of answers that say it's because relational database management systems have relationships. But I'm going to tell you that's a load of garbage. That's not why it's called relation. The real reason is because it has what's known as relations. Relations is this fancy mathematical term that they use to basically describe tables. Right? So tables, you know, we talked about tables. They have a table name, columns, and rows. All you gotta know is relations equals tables. Alright, now if you're anything like me, you're probably wondering what happens when you have a table and someone doesn't put information in it. I know that's what you're thinking. Well, if that's the case, you get something that's called a null or a null. I don't care how you pronounce it. A null is basically the absence of a value. So if you have a table and you have a column name, and this person goes in your database thing and tries to put information in, and they forget to put their name in and submit it, well, for that row, for that person, there's not going to be a value there. So to represent the lack of a value, the database uses the term null. That means it's missing a value. You'll often hear the term null value, but that really doesn't make sense because null, by definition, means the absence of a value. So to have a null value is contradictory. It's like an invisible seeing. Now you're probably wondering, how in the world can I prevent null values from entering my database? Well, there's tons of different ways. For one, they're not always a bad thing, but we'll talk about that later. But a really good way is through database design. Database design is a process we do before we create the database and also while we have the database to improve it if necessary. Its purpose is to protect the integrity of our database. And what exactly do I mean by that? Well, let me give you a really good example. If we had two tables here, let's say this is a user table, or users. Whether you use plural or singular, we'll talk about that later, but let's say we have a users table, and then we have over here, we have a orders table. If we have an order from users, there's some kind of connection here, because the user places an order, and the order is placed by a user. So there's what's known as a relationship. So this is a relationship. The integrity right here is having this connection. We need to protect that. If we get rid of this, for example, and we have this guy over here, and he buys a hammer. Okay, I don't know what that is. But if he buys a hammer, and then this user gets deleted, and then it says this hammer was bought by this user and he doesn't exist, that's a problem. That's a fault in the integrity of the database. So we got to prevent that. So we design our database in a way that protects the integrity. And we'll get more into that as we go on. So we already talked about relationship. This is a connection between two tables. Now, there's something else that is important to know about tables. You're probably wondering, well, how do you keep every single row in a table unique? Well, that's something known as a primary key. You think about it, we have a table, we have all kinds of different entities in here. Let's say they're trees. We're keeping a documentation of all the trees that grow in our national park or something stupid, I don't know. And we have just multiple trees. Well, how do we keep them unique? Because we could have an oak tree, we could have another oak tree, this one could be 6 foot, and this one could be 6 foot. So now it looks like we have a problem here. Is this tree 6 foot and this tree 6 foot? Or is this a mistake in our database and we actually have duplicate data? One tree in there twice. That's an error. That's not good. So we need something known as a primary key to protect us from that. And generally, it's just a random database generated number. So we'll have something such as a tree ID. And that's just going to be like 1, 2, 3, 7, 12, 48. And basically every tree is going to have their own ID. So that prevents duplicate data. Continuing on that example, we could have that tree, right? And let's say we're running a tree store and we're selling these trees, right? So we also have a table for sales. And we sell that tree to somebody. That means we have a customer. The customer initiates the sale to buy the tree. Well, these are all connected. And the way they're connected is by the primary key being referenced in the other table. So these are all going to be tables. This will be a tree table, a sales table, and a customer table. And they're all going to be connected with relationships. How though? Well, we're going to have a tree ID, we have a customer ID, and we have a sales ID. To issue the sale, we're basically going to say this sale with the sale ID also has a customer ID because the sale had to be ordered by somebody. Now, also the sale is going to have a tree ID because the sale has to sell a tree. So basically, this tree ID and this customer ID is going to be replicated in the sales table. And this is known as a foreign key. Just to kind of illustrate that a little more, we could give a specific example of a sale. We could say the sale ID is 7. The customer ID is 743. The tree ID is 12. Now, we can basically take this and we can build the entire sale from this information. We're saying that the customer that has the ID of 743, let's say it refers to this guy, is buying a tree with the ID of 12. So that refers to this specific willow tree or whatever with the ID of 12. So that connects to that. The sale is talking about the sale itself. So this whole thing is labeled sale ID number 7. So we're going to have 3 tables in this situation. We're going to have the trees. So we're going to have the trees, the customers, and the sales. This is going to have a primary key. This is going to have a primary key. And this is going to have a primary key. That's because they all have primary keys. Every single table needs a primary key. The sales is going to have 2 foreign keys. It's going to have a foreign key to the trees, referring to their primary key, and it's going to have a foreign key to the customer's primary key. So now we have foreign key on the list. Now if you've made it this far through all of this information, I congratulate you because it's a lot really quickly. So don't get overwhelmed if you are falling behind. I have a 50-part video series if you want to go check that out over all of this information, but much slower. But if you're anything like me, you're probably wondering, when you have these primary foreign key relationships, how do you protect them from being broken? Well, I'm going to teach you that. That's known as a constraint. So in the tree example, a constraint would be the sale can't have a tree that doesn't exist. Another really good example of a constraint would be preventing somebody from deleting a tree or a customer if it's being referenced by a sale. So you have a sale and it says, oh, this tree was bought by this customer. Well, if someone goes in and deletes that customer, well then we have an issue because it's saying that this tree was bought by a customer who doesn't exist in the database, right? That is an issue with database integrity, which is part of database design. So when we design a database, we get constraints to protect the primary and foreign key relationships. That's getting pretty intense. Now if you're wondering, how in the world does the database keep up with all of this information and processes so quickly when you get all these sales of trees and stuff? Well, I can answer that question. You're wondering about indexes. Indexes are basically when you take a certain column in a database. A column would be a single attribute of multiple entities. So, like the name, you can take everybody's name and you can make an index for it. What that index does is allows the database to find that information faster. And we can talk more specifics of indexes in the future, but for now, that's all you really need to know, except that primary keys are going to get an index automatically. So I'm just guessing that you're probably wondering, how in the world does a database keep all of the different types of data organized, such as, well, we have phone numbers over here, we have names over here. How does it know what type of data it is? Well, that, my friend, is known as a data type. A data type is basically the kind of data you are assigning for a column. If we have this table and we have a column named name, well, you should expect that every single value within this column for every single person is letters. So we can assign a data type to this name of string, for example. That's just a kind of data type. That covers all of the basic vocabulary that I covered over the course of like a billion videos in my other courses. So if you need a slower version, check those out. Otherwise, write all these down, get the definitions figured out, study them a little bit, and then move on to the next video. Thank you guys. Welcome back to the second video in this 5-video database design primer. Ready to have your brain exploded for the second time today? Let's get started. So I'm going to try and take it just a little slower than the last video, but this is going to be about database integrity. And I talked about this a little bit in the last video, and this camera just looks a little too close, so I'm just going to back it up a little bit. So in the last video, we discussed database integrity just a little bit, but in this video, I want to go in much more depth. So let's talk about integrity. Database integrity is a thing we try to have in our database. Basically, it protects our database from breaking, having incorrect data, and so forth. So to make the whole concept easier and easier to discuss, they break it up into 3 categories. So the first one is entity integrity. The second one is referential integrity. And the third one is domain integrity. Now before we discuss the 3 categories of integrity, I want to discuss one thing you should always try to do when you're building a database. Always try to make things built off of singularity rather than plurality. I don't know. That made no sense. So let me just kind of describe it. If you have a table, you have a table name. So let's say it's user or users. And you're probably wondering, whoa, that is not singular. That's plural. Yeah, it's right. It is plural. But the thing it's talking about is one individual thing. It's users. That is one thing. It's not users and customers. It's not users and professors or whatever. It's just users. So this talks about one thing. So the primary goal is to make everything atomic. So if you're wondering what atomic means, think of an atom a long time ago when we were not able to split an atom. Well, that basically described what we were trying to do with a database, where we have chunks of information that aren't meant to be split. So you can't break this table up into anything more. You can't break it up. If it was like users plus customers, well, you could split it, have users and a customers table, have 2 separate tables. That would not be atomic. But since we have just users, it does make sense. It's atomic. It's only one thing. It's basically just a general. It's basically just a general entity, and then within here we're going to have specific users. So that's one thing you need to know when we're making databases. So when we have columns, we make the column's title be about one specific thing. So phone number, a first name, a last name. We generally want them to be things that are atomic. For example, an address, that's usually more not so atomic. Because if you think of address, you actually have a city, a state, a street address. You might have an apartment number. Those are multiple things within that one column. And we want to avoid that. So that's the very first thing. Now when we're discussing entity integrity, that means everything needs a primary key. The primary key is used to keep everything unique. So you have basically an ID, which is a type of primary key that's known as a surrogate key. We talked a little bit about that in the last video. Surrogate keys are just random numbers that are generated by the database that have no real-world value. If you do pick a natural key, you want your natural key to be something that doesn't change. So the primary key doesn't change, and then we have a couple other rules. Well, for one, it's not null. If you remember from the last video, null means the lack of a value. So there is no value there. So you can't have a primary key that doesn't have a value. If the email is the primary key, every single person or every single account is going to need an email. The third thing is that it should be unique. You shouldn't have 2 entities with the same primary key. If we have a guy here and a guy here, and this guy's ID is 106, and this guy's ID is 106, the database will assume that these are both the same people. And that's not the case because there's two of them. So these are known as constraints. It's basically setting rules for the database that's saying, don't be null, or everybody has to be unique. And that's just some examples. There's more constraints you could add. For example, there are referential constraints, which is what we'll be discussing now. Referential constraints connects tables. So when you have two tables,
Call from Josh Parsons.
when we have two tables and there's some kind of connection, we'll have a primary key in this table, a primary key in this table, and then one of the tables will reference the other table. So if this is users and comments, well, the comments is going to reference this table. So we'll have a foreign key that references that primary key to say that this comment was posted by this user. And that's all done using the primary key. That's the connection. Now, if we want referential integrity, we have to protect that using constraints. Constraints are basically rules that don't let you do certain things to destroy the database. So for example, if we did not have constraints and we had this foreign key connection, well then we can make it to where if we delete this person, he's off of there. And this comment still exists. That doesn't make sense because a comment can't exist without somebody posting it. So then we're going to have all these comments like, wow, and it's going to be by null. We don't want to see these kinds of things on a website or application because that's not good at all because you don't know who said it. It's just bad. So that's referential integrity. The final one is domain integrity. Domain integrity is basically giving a list of possible options for columns in a table. So if you think of a table, we could have a table for the users, just like this table up here, but I'm just going to draw so we have more room. And I'm just going to list the columns this way. So don't think of these as rows, we're just listing what the columns will be. So the table is a users table, and we might have a USR underscore, then user underscore ID underscore PK. So basically that long nonsense is the prefix of user table, the user ID, and then it's the primary key. That's one column we might have. Then we might have the name, username, and if you wanted, you could break name up into first name, last name, so that way it'd be more atomic, if that's something you would like to do. User password. So these are just some examples of columns that you could have. And if you notice, I did this a little differently, because normally I'll draw a table out like this, and put the columns up here, and then rows across this way. Well, this design is actually pretty common. So basically we're just setting all the rules of what the rows are going to have, but we don't actually write them in. This is known as basically an entity relationship diagram. So that's ERD. Entity relationship diagram. And you'll see these connected to other tables. So you might see something like this. And you'll see big charts where it'll have the table and the columns for that table and different types of relationships between tables. That's an entity relationship diagram. But in this situation, we're going to implement domain integrity by preventing certain entries into these columns. For example, the username. We can make domain integrity by saying that everybody's name should be characters. It shouldn't be a data type that is not a character. So if we wanted to do that, we would give it the data type of string, for example. When we make it a string, it's not going to allow people to put the data type that's numbers, or the data type of dates, or the data type of true and false. It might be able to store those values if you don't put enough constraint. For example, it can be a string, but that string might say true. Whereas when it's in quotes, we're running out of space here. When it's in quotes, it's known as a string. And we'll get more into the specific types of the data types really soon. But for now, just know string is with like the quotes. But this very well could also be true without the quotes. And if that's the case, then this is not referring to a string, but this is a Boolean, which is either true or false. So that's what I'm saying. You want to make sure it's the right type. You don't want to allow number data types or Boolean. You want it to be string. A couple other things you can do is you can say how many characters you want it to be and so forth. So for an email, you should be able to check like, well, is it at least 3 characters or whatever the shortest email length is. You can try to go in more depth and make regular expressions with software to check your email. You want to add domain constraints that prevent people from putting garbage in your database and making your database all messed up. You can also do conditional statements to test data. So you can say if the sex that the person enters is either M or F, then insert it. But if it's something else, like cats, well, you don't want to put that in there, so you can say, well, don't insert it. That's an example of just some different types of integrity that you can put in your database. You're a dork. So yeah, guys, that's all I have to say about integrity. So thanks for watching, and I will catch you guys in the next video. Peace! And be sure to subscribe. Ow, my ankle. I just kicked the wall. Be sure to subscribe. Hey, what is up, everybody? Welcome back to your 6th Oracle SQL tutorial. This video we're going to be talking about relationships. Alright, so this is a straight up dating advice tutorial. Alright, this will get you all of the ladies. By all ladies, I mean probably 0 or less. And yeah, it might get you a programming job though someday. So, alright, so let's begin. We're going to start talking about relationships. And if you don't know anything about database relationships, this is the tutorial for you. Well, everything in a relational database has relationships. And when we say relational database management system, you guys remember that? I think I talked about that. Relational database management system. Well, this R does not mean relationships. It means relational, which deals with the concept of relations, which has to do with tables. So basically a relation is just a table. So when I say relationship, just want to make sure you guys are clear that don't be going around saying relationship database management system or something like that, because then you won't get the job or the ladies. Yeah. So before we go about designing these relationships, let's just talk about some conceptual information that you should know before you start diving into the whole diagramming stuff. Alright, so the first thing are the 2 words you need to know. Entities and attributes. These are basically 2 kinds of information in your database. An entity is anything we store data about. An attribute are the things about that entity. That means an entity has attributes. Okay, so in this example, you can see this entity right here has an attribute, an attribute, an attribute, and an attribute. So basically the attributes describe the entity. So how do you know if something is an attribute or an entity? Well, if you can think of a bunch of information about this, okay, just think if you have an object, right? Just something you want to store data about, or something you want to store in a database. And you're asking yourself, okay, is there a bunch of stuff I can store about this object or this thing? if there is a bunch of stuff you can store, then there's a high possibility that it is an entity. If you can't think of anything that you need to store about it, then the likelihood is that it's an attribute. Now, sometimes you can make it work either way, and I'll be explaining that. So don't get so caught up like, oh my goodness, I don't know if this is an entity or an attribute. Usually, once we get into database normalization, that'll kind of work its way out. But when you start off with just some basic entity, attributes, and relationships designing stuff, then when you get into normalization, it's like a piece of cake because you basically already have it done. All right, so let's kind of just go through some examples, right? If you have a database for a college, and this college has a class. This class would be a specific class, so we could say it's Math 4070. Now this would probably be our entity. That's because there's going to be related information that's going to describe this class. So we could have, a professor, student, have room number. So that's going to say where the class is located in the school. And if it's a big school, you might have building and room number. But we'll just go with room number for now, for simplicity's sake. And you also might have a time. So we could just say Tuesdays at 4:30 to 5:30. It's a pretty short class, only once a week, and it's only an hour. There's a whole bunch of information here. I just want to try to go through this and try to figure out what would qualify as an attribute and what would qualify as an entity. So you look at this and you kind of just ask yourself, all right, can we store information about each one of these? For example, a room number. Can we store anything extra about a room number? Not really, it's kind of just a room number. It might be 432, right? What about a student though? Well, a student, that's like kind of important. It's like a human being, and human beings are pretty important, So the chances are you can store information about a student. So, you could have what's their name, what's their student ID, what's their major, what class are they in, stuff like that. So this would probably be an entity. Professors, same thing. Those professors, they're people sometimes. Now, what about this time of the class? Well, can you say anything about the time of the class? Not really. That would probably be an attribute. So when we break this off into entities and attributes, let me clean off the board a little bit, we get something that looks a little bit like this. We have a table, and we can place the entities over here and the attributes over here. So for the entities, we have the class, the student, and the professor. We also had some attributes that were specific to the class. We'll just put these over here now. So you can kind of see how this is working. We're separating the entities from the attributes. And yes, these attributes are very specific to just the class. But that being said, we could add more attributes that describe the other entities. A name. Well, that could describe a student or a professor. Birth date, same thing. That could describe a student or a professor. What about a major? Well, professors could teach in a specific major. For example, we could have a nursing professor, but generally when you're talking about a major, you're talking about students. And I don't know why I decided to do those ones in black. Let me clean that up a little bit. Oh, I think I just made it worse. But you guys follow. Well then, what does this mean when it comes to database design? Why did we do this? Why did we waste our time making this graph? Well, we actually didn't waste our time. The way this works is you will take the entities and you will make them have their own table. So each entity is going to get a table. Attributes, on the other hand, are only going to be a column within that table. Without worrying about all the details, you can get a basic database design by following this concept. That means we have three tables. We have the class, the student, and professor. As for the attributes, such as the time of the class and the room number, those are just going to be a column within this class table. So within this class table, we're going to have those two columns, room and time. As for those other attributes we were talking about, such as name, well, those are going to go in both of these tables. You can get a very basic database design starting point using this method. Now we talk a little bit more in depth about the concept of relationships, because these tables relate to one another. For example, a class is taught by a professor. Students attend the class. You could also maybe say that the professors teach the students, or the students learn from the professors. So we're going to talk about the 3 types of relationships right now. The first kind of relationship we're going to talk about is a one-to-one relationship. And if you're a visual learner and need some kind of picture to visualize this, think of marriages. Alright, I probably wouldn't be cool if my wife went out and married another dude, right? And I don't think she'd be happy if I went and married out some other chick, okay? It's a one-to-one relationship. Like, we have exclusivity in that we're not allowed to go marry other people. And if you're not a visual learner and that is just the dumbest thing you've ever heard, then forget it. One-to-one. This is the relationship of an entity and an attribute. So when you have an entity such as a class, the attributes would be the time of the class and the location of the class, and the class name, the class ID. Stuff that is unique to that class. Just wanted to mention that there is a little bit of flexibleness allowed in this. For example, when we say one-to-one, we're basically saying this class has one name, and this one name is assigned to this one class. Now, like I said, that's not always generally true, because we could potentially have another class with that same name. But if you think about the purpose of a class name, it's an attribute to describe an entity. I'm really not trying to make this too complex, right? So I'm trying to give you the most technical, correct definition of this, right? A one-to-one relationship is essentially a column within a table, and that column is unique to that entity, even though the value of that column could be repeated in another row. Did I lose you? I think I just lost myself. Let me give you a picture, right? We have this dude, and we have this dude. There's a couple different ways we could store this in a database. First, we can put them both in one table, and we could make them both have their own row, which would be the way we would want to do this. And now this person has a name. So we have a Caleb, and we also have a Caleb. This would be the proper way to design this. One-to-one relationships, you put the attribute as a column within the entity table, which will be people. Sorry, my neighbor's parking his car, making a bunch of noise. What a noob. Attributes are a value within the name column, and they are unique to each entity, but there's a repeating one. So an alternative way to design this, which you should not do, is to make another table known as names and have Caleb in here once with an ID. So let's say this has the ID of 1. And then we could reference that. That's a total possibility, and in fact it would work. But it's unnecessary strictness. Just because there's a possibility that the attribute could be repeated doesn't necessarily always mean that it's a one-to-many relationship. If I haven't lost you yet, good. If I have, let's just slow down a little bit. The only thing you really need to remember or think about is that a one-to-one relationship is an entity and an attribute. That's all you gotta know. Just ignore all this stuff, you know. The second example of relationships that you need to know about are one-to-many relationships. Now when we're talking about one-to-many relationships, we're starting to talk about relationships between two entities rather than one entity and one attribute. In this example we had an entity and an attribute, but in this one we're actually going to have a relationship over two tables. And if you remember, I was talking about entities. I said each entity gets their own table. So the example I got for this one is you got like a gym, right? Generally, gyms will have some kind of membership, right? Some gyms have a tiered membership system. You can find the same thing on websites. You can pay $10 a month for the good version, and then you can pay $10.99 per night for legit version, right? So those are like a tiered membership. So let's say in this theoretical gym we got 3 tiers. We got bronze, silver, and gold. So over here we have the membership table, and we have 3 entries or rows. So these are basically going to be 3 rows in our membership table. And over here we have customers. And don't worry too much about my spelling or anything. We'll get into all that later. I'm just using for theoretical design. I'm just writing what I'm talking about. I ain't following no standards. Well, in this table, each customer is going to get a row. So we have 3 customers. Each one's going to have a membership status. The way this works is with an ID system. Each one of these is going to have an ID. And with these numbers, you can basically correlate it. So this guy, he is the gold membership. This guy has the silver. And this girl has bronze. Or let's say she has gold too, right? That's how that works. And just so you know, you don't have to use IDs, but you need some kind of primary to foreign key relationship, which we'll talk about that in a couple minutes, if I got time. This is an example of a one-to-many relationship because one membership status, gold for example, goes to many other entities. So we have 1 to this guy and to this girl. To follow this, you got 1 to many. Many being more than 1. It doesn't have to be like hundreds, it can be 2, for example. So that's the way this kind of works in a one-to-many relationship. There's a connection between the customer's entity and the membership entity. So in a one-to-one, you have an entity and an attribute, but in a one-to-many, you have 2 entities. And once again, for your visual learners, this would kind of be like if my wife was like, yo bro, I know we're like married and such, but I'm gonna have multiple wives. I'm gonna have multiple husbands, but you're not allowed to have multiple wives. That's not cool, and if you do, we're done. That's kind of what a one-to-many relationship is, because you'd have one husband has 1 wife, but the wife can have multiple husbands. Sorry for all the details, but getting on to the final, and probably your future least favorite of them all. Many-to-many relationships. I can talk. The way many-to-many works is that one entity could have a relationship with multiple other entities, and each one of those entities could have relationships with any number of other entities. So kind of be like, yo, wifey poo, I know we're like married and all, but I think we're gonna be allowed to have as many wives and husbands as we want. Or that would be full polygamous marriage. But to put that into a data perspective, let's use a different example. We have people, and then we have classes. So students and classes, essentially. One student can take 20,000 classes, and one class could have tons of students. So if you think of you have like one student, and that student has a relationship with multiple classes, it'd be like, poof, poof, right? Like pointing to 4 classes, for example, you get like this effect. You know? And then on this side, you have one class which has 30 students. So you get like times like a lot, right? And then you just get these lines going all over the place, right? And at the end, you just got this big mess, right? So this is one of the harder ones to store in a database, and it requires what's known as an intermediary table. You may also hear this as a junction table or a many-to-many table, or who cares? There's all kinds of different names for it. But basically, the way this is going to work is you're going to have 3 tables. And this here, this intermediary table, is right here smack dab in the center of them, separating them. You know, you don't want all those lines crossing over each other, so that'll just be bad. And then you're going to put all of the relationships in this table. So within this intermediary table, let's say this table here is students and then classes. So we got students, classes. Within this table, you're going to associate a student with the class that that person's taking. So you would have Caleb, math, Caleb, science, Caleb, geology. And then once you go through all the classes that Caleb has, you go on to someone else. Jimmy, math. But Jimmy doesn't have a science class. So you just go straight up to geology. And these names are going to be replaced with IDs or foreign keys to the students table. Did I lose you? But basically, you're going to have, let's say Caleb has the ID of 27. Instead of having Caleb, you're going to have 27, 27, 27. And that's going to link the tables. So that way you don't have them break apart. So there's still that connection, links, but they both come to the intermediary table and stop there. For you visual learners, think of like two tables shooting out laser beams. Boom! And then it hits this magical force field of this intermediary table, and it absorbs all the electrical energy juice and then puts it in a beautiful display of students to classes. And right now you don't need to understand all the details of how to make an intermediary table perfectly. If you want to know more about that, I have a 50-some part database design series that you can go watch for days, okay? I'm just trying to get the basics, and this video has been way super too long, so let's just end with that for the relationships, but I still have one more thing I need to talk about, which first we'll summarize this, and then we'll talk about primary keys and foreign keys. So many-to-many is also entity and entity connecting multiple entities, but with an intermediary table. So entity and entity with intermediary table. That is how we would memorize that. And if you like to think about tables, like how many tables do these things take up? This is 1, this is 2, and this is 3. Okay, now let's talk about primary keys and foreign keys, and then we'll talk about one more thing regarding relationships regarding those keys, and then we'll be done. So there are two types of keys in database design. There's primary keys and foreign keys. So these are the kinds. Now there's also categories. So those two categories are natural and surrogate. These are basically the way the keys work. So natural would be something that has real world meaning. So something like an email address would be a natural key because it has real world meaning, like I just said. A surrogate would just be like an ID of 743, which is just a random number, computer generated, doesn't mean anything in real life. And the fact that it's just a random number, that's it. But I guess I skipped a step. What are keys? They're basically things to keep things unique. The keys are used to basically make every single row within a table unique, and also they're used to make connections across multiple tables. The difference between natural and surrogate is minor, and it's kind of a conflict between database designers as, oh wow, you should use natural, or oh, you should use surrogate, or oh, you should mix them. It's not a super huge deal in reality. I tend to prefer surrogate, but I'm not completely against natural, so just for those of you who are wondering, natural or surrogate. But that doesn't matter. So let's just talk about primary keys and foreign keys. The primary key is the key column within a table that makes that table, which makes every row in that table unique, right? So if you have a users table for a website, every single user is going to have in this case, a surrogate key of a random generated number. That makes every single row unique. So that way, if you have a person with the same name as someone else, you can tell that they're different things, right? So if you didn't have these keys and you just had Caleb and Caleb, well then you have to ask yourself, okay, is this a duplicate or are these two separate people? And you don't really know. But if you have a key, one of them is named Caleb with the ID of 72 and one of them is Caleb with the ID of 483, well now you know they're two separate entities. One's Caleb with this ID and another one's Caleb with this ID. So let's just draw faces to represent people, and we're going to give each one of these people an ID. This face here, you wouldn't store that inside of a database. I mean, you could store a picture, but that's not what I'm trying to do. I'm just trying to give a visual representation of what each one of these rows refers to. It refers to this person. You know, it's like, how do you talk about the person? Well, it's this person. Got these three people. We'll give them some hair so they have some confidence. This one's a squid. Alright, so these three people each have a row in the database, in the table of the database. The table is whatever is what you're storing, so in this case, users. Now, a foreign key is a reference to a primary key in another table. So if this is that gym we're talking about, we would have a column foreign key, which would say membership status, for example, and you would have, let's say, 2, 2, and 3. These are foreign keys, and they reference primary keys of another table, which in this case would be membership status. Each one of these is going to have a primary key. Every single table is going to have a primary key. If we're using IDs, well, we could just say 1, 2, and 3, just computer-generated numbers. Now there's a link between the foreign keys and the primary keys. See this number here? Well, this is a foreign key, and it has to match a row with the same primary key. So this foreign key references the silver. This one also references silver. This one represents gold. And you have these links, and you can enforce those links with something known as foreign key constraints, which we'll talk about in a future video. That is basically how this works. Primary keys, foreign keys. Foreign keys reference the primary keys. Every single table needs a column that has a primary key to make every single row unique. Then you can enforce that with foreign key constraints. So when it comes to those database relationships we were talking about, the way we design our primary keys and foreign keys are very important. So we're going to go through them real quick and describe how this works. The first one being 1-to-1 is the easiest. You guys will love it. All right, you don't even need to worry about multiple tables. You have a table, and then one of the columns is going to be the primary key, and then you put the relationship in another column. It's simple, entity and attribute. The entity might be users, everyone has their own ID, and then an attribute would be like the user's name. Caleb, for example. That's all you gotta do. You make a column. Boom, done. Simple. I know, it's awesome. I wish it was all like that. For one-to-many, it's a little different. Let's use the example of the membership again. You're gonna have two tables, and this one it's going to be the users. So you're gonna have a primary key of the user ID, and then you're going to have a foreign key which references the primary key of the membership. The foreign key goes in the child relationship, which we never even discussed really that much, children and parents, but you can think of it like this. You can have one entity, such as gold, which can be used or whatever by other entities. For example, Caleb and Sarah and Samuel. Right? This will be the parent, these will be the children. Well, these people are all stored inside of a table, each with their own row, and then the foreign key, each one of these has a foreign key. So this is going to have a foreign key of 3, foreign key of 3, foreign key of 3, because they're all gold members. It makes sense. So for one-to-many, the one side has a primary key, the many side, which would be the children, has a primary key and a foreign key referencing the one side. Huh, great. All right, let's go over many to many. In this situation, we get 3 tables. And let's say it's books and authors. One book can be authored by many people, and one author can author many books. So you got this many to many relationship. Well, we can put books over here, authors over here. The foreign keys are going to go in here. So you're going to have a foreign key to the book and a foreign key to the author. Now there's one small thing of debate that some people have as to whether you need a primary key to describe the whole group. So if you did, you'd need 3 columns. If you don't need the primary key, then you just use both of these as the primary key. I'm just going to say up front it doesn't really matter, but in this situation we'll just keep it as this. You can interpret it however you like. But basically, the foreign key is going to reference the book, and the foreign key is going to reference the author. So you could have one author, this person over here, with the ID of 47, who authored 3 books, 38, 27, and 19. Those are the IDs of 3 books. The way it look in here, you would have 4738, 4727, 4719. That is how a many-to-many relationship works. Well, congratulations. If you've made it this far, you officially got through the database relationship section. One of the most fun and interesting sections, but it can also be very time-consuming because it's very conceptual and, you know, kind of annoying, and you kind of just want to, like, take the whiteboard and smash it on something to help you think or something. I don't know. But hopefully that was helpful. Sorry, this is probably one of the longest videos I've ever posted. But anyways, thank you for watching. I'll see you in the next video, and hopefully you guys are learning and enjoying this. Thanks, and I'll see you then. Peace out, guys. Peace. Peace. Hey, what's up, everybody? In this video, we're going to be covering database normalization. So this is your 4th video in the 5-series database primer. Essentially, my goal here is to kind of give you like a rough overview of everything database design. But naturally, you can't learn everything about normalization in just one video. So this is going to be something that continually shows up in future videos and throughout your database career. So don't blow this off. It's pretty important. So database normalization is basically a set of rules that you can optionally follow, and it will help you get a better, more protected database design. It protects your data integrity, it prevents redundant data and contradicting data. Like, oh, here's John, his phone number is 123 whatever. And then, oh, here's also John, his phone number is 457 something else. And then you don't know which one's right. So these are the kinds of things we want to avoid. And the main ways we design a database is 1, with relationships, and then 2, once we kind of got those relationships designed, we start doing normalization, which is kind of like a check that looks through your database and catches anything that might not work the way you want it to. But you guys got to realize that a lot of these decisions, like, oh, should we design it this way or should we design it this way? These are things that are decided by the business rules, your assignment, what you need for the project. You can't always look at a table and say, what's the correct way to design this? Because it depends upon what the requirements are. You can choose on certain things. But I'm kind of getting off topic, so let's get started. The 3 normal forms are first normal form, second normal form, and third normal form. There are a couple other ones after that, but who cares about those? Let's start with the beginning ones. So we're going to start with the first normal form. Now the first rule of first normal form is that all of your columns need to describe something that is atomic. What does it mean if something is atomic? It means that it is in its lowest form, like the most you can divide something up. The reason being is that one time these science people believed that atoms were the smallest thing, and they assumed that, oh, you can't split an atom, right? Pretty helpful. How's that apply to database design? I don't know, but we're using that word. So essentially, we want the column headers, or whatever the column is about, to describe one individual thing. But don't make it so small that it loses the meaning of what it is, right? So there's like a fine balance. So like, for example, we have a phone number, right? So here's my phone number, and this is something that is atomic. It's the smallest indivisible thing that can describe a phone number. If I wanted to split this up, like let's say I split that, now you have to do some extra combination like, oh, the area code and junk, but I would say that the full number qualifies as being atomic. When it comes to names, I would say first name is atomic, middle name is atomic, and last name is atomic. If you just combine all of those into a column like name, I personally think that's not very atomic. You can do that though. It's up to you. One reason that might be good is for different countries, names are separated different, so people don't always have first, middle, last. They might have like first, second, middle, second middle. I don't know. I don't have an eraser. Don't worry, t-shirt to the rescue. So as a reminder, the first part of first normal form is that the columns are atomic. The second part is that the data for each row is one thing. So it's similar to things being atomic, but now it's the number of items that are not divisible. So if we go back on the phone number, so if this is my phone number, this whole entity is atomic. You wouldn't want to split it. That puts you at risk of making a nuclear bomb. So we're just going to keep it at that. But what if I have two phone numbers? So now in our database, we have a column phone number. And within an individual row, for me, I have one phone number and then I have another phone number. How do you go about storing this? Are you just supposed to put them both in there as one giant string? No, that'd be stupid. You don't want to do that. So this is an issue. Databases are designed to be atomic. We don't want to put a bunch of junk in one thing of data. Because if you wanted to go through here and grab phone numbers, you might say something like, oh, select the phone number from this table, and it returns this. And then you try to like automate a phone calling system or something. This isn't going to work because these are two things. But how do you actually fix this? Whenever you have the situation where you might have multiple entries for one person, you need to create another table. Now when it comes to phone numbers, some people will just put phone 1, phone 2, and leave it at that. And if they don't have a phone 2, then they'll allow you to put nulls into that field. But some people prefer to have no nulls in their database. And if you don't know, nulls are just the absence of a value, so no phone number. But if you want to force, we want you to be able to have unlimited phone numbers. And if you don't have two phone numbers, we don't want you to even have a second phone number. Because that's just wasted space, right? The way you would do that is you create a new table for phones or phone numbers. And then within this table, you're going to have two columns at least. The first column is going to be a reference to the person. And the way you do that is with a foreign key. So this might be an ID of a person. And then the other column is going to be the phone number. So let's say we have a person over here, and he has an ID of 7. We're going to put an entry over here, 7, and then we're going to put one of his phone numbers over here. Then if you had another phone number, you would make another entry into this table with the same foreign key referencing this dude, and you would put his second phone number. This solves that problem of having phone number 2, null, 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 null for like everybody. So the way it works, the way it prevents nulls is if we have another person and her ID is 8 and she only has one phone number, you only need one entry in this table. Problem solved. So to conclude first normal form, every column is atomic, and then every entry for that column only has one value. Let's move on to the second normal form. Second normal form deals with something known as partial dependencies. So before we dive in and talk about what partial dependencies are, let's just talk about what normal dependencies are. Essentially, dependencies are when an attribute depends on an entity, or basically it describes the entity. So this goes back to like the very basics of databases where you have attributes and entities. So if we had a person, this would be the entity, and an attribute would be the name phone number. I was looking back at my old videos, and one of the attributes I used was their pH level. Really? So let's go with it, their pH level. All of these attributes depend on the person, meaning that if you change the person, these are also going to change. So usually this entity is described with a primary key. So usually it's an ID, but not always. That's called a surrogate key, meaning the database just generates some random number to represent an individual person. So that's what we're going to go with. But if you don't want to use random generated numbers, you can look into natural keys. But those are complex, so forget that. So let's go with person, and we're just going to make this a person ID. So everything depends on the person ID. That also means that this person's name does not depend on something else. Like an order, this order is placed by a person. So we could say the person with the ID of 46. But this name is kind of unrelated to the order. So you got to be able to tell where a dependency is and where a dependency is not. The easiest way to think about it is usually the columns in a table all depend upon the primary key. But occasionally we run into something known as a partial dependency, which is bad stuff. So we're going to teach you how to get rid of it. So as you may have guessed, partial might imply meaning like part of something. So in order to have a partial dependency, you need to have what's known as either a compound or composite key. Essentially, two keys combined to make one key. The reason that is you can't have a partial dependency if you only have one key, because you can't split that. You'll see what I mean. So we always need a compound or composite key when we are dealing with second normal form. So where do you find such compound or composite keys? One example is when you're designing a many-to-many relationship. The table in the middle, it's known as an intermediary table, it's going to have two primary keys. And the combination of those is going to qualify for something that might have a partial dependency. So let's dive in that a little bit more. So in the previous Oracle video, we talked about books and authors and book authors. And essentially what we did is we set one table as books, one table as authors. Because books and authors are a many-to-many relationship, essentially what we're going to do is split this off into into two tables with a one-to-many to a third table and a one-to-many also from this side. So essentially one many-to-many is split into two one-to-manys. Hopefully that makes sense. It's basically this rather than, because this is not a good design for databases. So over here we're going to have books, over here we're going to have authors, and in between we're going to have, you guessed it, book authors. So in this table we're going to have a book ID and an author ID, and the combination of these two need to be unique. For example, if we had the book 47, like the ID 47, and the author 47, and then we had another entry 47, 47, this would be describing the same thing. It'd basically be saying, hey, this guy wrote this book and the same guy wrote the same book. It's redundant, so we don't need that. So essentially we put a, kind of like a, oh, drop my chalk, kind of like this overarching key on both of these. So these as a whole need to be unique. So we could have 47, 43. These don't have to be unique, but both of them together have to be unique. All right, now let's say we have some super meaningful data, like the author's favorite food, because that's relevant. And you're like, I wonder where I'm gonna store this. Yeah, let's put it right here. So we have the author's favorite food here now, but we just introduced a partial dependency because the author's favorite food only depends on one of the two keys that make the overarching key. So it only depends on the author. And the way you can kind of think about that, or basically prove that, is you can change one of these and see if this changes. So if we change the author, the food that that author likes is going to change. Because if we had an entry in this table and it was like, oh, John, he likes tacos. And then we had another one like, oh, Hannah, she likes mac and cheese. We basically looked at the difference from John to Hannah. The food could potentially change. I mean, they could both like the same food, but we're just talking could change. But if you go through the books and you change them, this is always going to stay the same. The food is not going to change. So, oh, John, he wrote Three Little Pigs. His favorite food is tacos. Oh, John, he wrote Mary Had a Little Lamb. Is that even a book? I don't think so. But his favorite food is still tacos. You can see that it really has nothing to do with the book. So the appropriate place to put this, as you guessed it, is over here. That would fix the partial dependency. But this also brings up the question, when is it appropriate to put something in here? And the only time is if it depends on both of the keys. So a good example is the author's position on a published book. So you know, authors, they get all like mad because they want to compete for like the #1 author, right? Like the first person. Because then basically they kind of get most of the credit for the book. So that's something that might be important if you're a publishing company, is what position that author is for a specific book. But as you can see, it kind of depends on both, because it depends on who the author is and what book you're talking about. If you were over here and you said, oh, John, he's position #1, but that doesn't tell you position #1 for what book. But if you put it over here, you can say, oh, Three Little Pigs, position #1. Doesn't really make sense. But if you go in the middle and you say, oh, John is position #1 on the Three Little Pigs, now it makes sense. So in that situation, you would not have a partial dependency, and the correct location would be is to store it in here. So hopefully that kind of sums up second normal form. It's one of the more complicated ones. It's taken me a couple years of my life to really meditate and grasp all the details of second normal form. But one day, young sir, you will get it. Or ma'am. Moving on to third normal form. This deals with something known as transitive dependencies. These ones are a little easier, so relax. So what in the world is a transitive dependency? Essentially, it's when you have a column that depends upon 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 a key. You have like this weird hopping thing going on. And it doesn't have to be that many levels. It could just be like a column depending upon a column that depends upon the primary key. Yeah, I know that's like really conceptual, so the easiest way to show this is to go through an example. So let's say you are a publishing company and you have this beautiful website where people can go on there and put their ratings for all of your books. And you know, these websites usually have some sort of star system or like, dislike. We're going to go with a star system, so that way people can go on there and rate their book. And it's generally accepted that like 5 stars is like, wow, this book is incredible, it made me win the lottery, it's awesome. 3 is like, yeah, this was okay, and then 1 is like, wow, this book gave me Lyme disease. Okay, so we kind of understand that, but let's just say you wanted to store what those stars meant in a database for some reason. You might try something like this. Inside of a rating table, you might have the user's comment, their star rating, and then you're going to have their star rating meaning. Now you may already see the problem here. The problem is that the star rating meaning does not belong in this table. We have a transitive dependency. That's because the star rating depends on the comment, and then the star rating meaning depends on the star rating. It's kind of like this bouncing thing. So the way to fix this is to create another table. You could just name it whatever, stars. Now within this table you could have the ID, and then you could have the rating. So you could say rating 1, 2, 3, 4, 5, and then another column for the rating meaning. And then inside of this table, instead of having both of these, you would just have a star rating that would be a foreign key to one of the rows inside of the stars table. So let's just go over an example. So here is a row in this table. super great, and then a star ID of 5, which could conveniently correlate to like 5 stars, but it doesn't have to. And you might also have like a user. Now, I'm gonna kind of comment my opinion on this. Putting the star meaning in a database is probably unnecessary, mainly just because 1 through 5 stars is kind of universally known, like 1 is bad, 5 is good. So do you really need to put the meaning in here? Plus, programmatically, in like whatever programming language you're using to make an application, you could put that phrase like, oh, this is 5 stars, great. You could put that on the application, but you don't necessarily have to store that in the database. You could just put it in HTML or whatever you're using. So that was a pretty simple example, but it wasn't the most practical example. But there are plenty of other examples. For example, you could have a person table, and one of the columns in that person table could be the person's driver's license number or something. And then another column could be the state in which they got their driver's license. But does that actually belong in the person table? Is the state that the person got the license in related to the person itself, himself, herself? Not really. That would be an appropriate situation where you could break it off into like driver's license table or something like that. Now that's with a compromise, because now you have an extra table, you have to do more joins, and the database design becomes more complex. So the lesson learned from this video is that the whole normal forms and database design is very subjective, and it really depends on what you want. So if it was me, I'd go on like the more simple side and don't normalize it too much. But if you do that at work and get fired, I said nothing. Nothing. Thank you guys for watching. I've been trying to give these videos in a very conceptual way, so that way this stuff applies to every single relational database you guys use, whether it's Oracle, SQL Server, MySQL, etc. The concepts are what's important. If you know these concepts, you can design a database in whatever database management system you want. Keep that in mind as you go on to the next video, which is the last video in this 5-video database primer. But in that video, I will try to give you some more information on what we're going to study relating to just Oracle database design. For example, different data types and all of that stuff. That stuff's going to come a little later, but this is the foundation for it all. So thanks guys, keep at it, keep with it. See you in the next video, and I'm hoping you're enjoying this series. Thanks, bye. Hello there! Welcome back to your Oracle database tutorial series. This video we are going to be discussing indexes. Now the easiest way to understand indexes is, let's just imagine you have a book, right? And you want to find something in this book. What do? Well, you could, go through it one page at a time and try to find what you're looking for, right? And eventually you're going to find something, but maybe not exactly might not be the fastest way of doing things, because it's going to take you a lot of time. So you use something that's known as an index, which basically you just pop to the back, and it's going to be like, oh, you're looking for this? You need to go to this page, and so forth. So that's the easiest way to think of an index when it comes to database design. Essentially, an index is going to take a column, and it's going to sort it in some way that you want to sort it, either ascending or descending. And then it's going to basically have a reference to where that data is. So that means if you're going through your table of users and you're looking for a specific username, as long as that username column has an index on it, you can just type in the username, it will alphabetically find it, and then it'll have a reference to wherever that data is, even if the table is not organized alphabetically. Another way to really grasp how useful indexes are is to imagine life without indexes. If you don't have an index on a column and you need to find a column using the select statement, for example, your database is going to have to do what's known as a table scan. This is kind of similar to looking through a book for something page by page. It'll essentially just go one at a time through all of your rows until it finds that data. That's not the way to do it. If you have it alphabetically, it's already going to know about where your data is, so it's a whole lot faster. Now we need to answer a question. What should you index? Well, thankfully, Oracle Database is actually going to index some stuff automatically for us. One thing that it will do that for is the primary key. The primary key is something we're often going to search for. We're often going to join tables using the primary key. And yeah, so we always want to have an index on the primary key, basically. Oracle's going to do that for us by default. There's another thing that it will automatically create an index for, and that's when we use what's known as a column attribute, unique. So kind of like how you can tell a column to be not null or what data type it is, you can also say unique. And that's basically saying every single row has to have a unique value. It's kind of like a primary key, but it's not the entity, it's just an attribute of the entity. Think of like an email for a user account system. The chances are your email is going to have to be unique. So you might throw the unique column attribute on that column. Now, I don't think Oracle does this by default, but another thing you should consider having an index for are your foreign keys. And the primary reason I suggest you do foreign keys is similar to why we have it for primary keys. It's because we use these keys to join data. So what is a join? Let's go into that a little bit so you have more of an idea of what I'm trying to explain here. Let's say you have two tables here. One is like a user account table and another is a comment table. You might have an individual comment that has the inside of the column of who posted it an ID of 7. But you don't have the ID of 7 memorized. You don't know who that is. So what you can do is do a join on these tables, and you can essentially turn them into one table. Now, it doesn't actually store it as one table, it only presents it as one table. And the way it works is it combines the tables based on some kind of similarity, basically. So for example, we might have a user up here with the ID of 7, and we might have a comment down here from the user with the ID of 7. Then, instead of having this as our table, we can have this. As you can see, this is a much better way to present this data because we know who the comment is from. You could also have the username here or whatever. You can combine things in so many different ways, and you could literally make an entire series on just joins. So that's all we really need to talk about for now. But essentially, anytime you're going to be joining two tables very often, you might want to consider indexing the columns that they share. So this one has a user ID and this one has a user ID, and you use those to kind of combine the tables. You're going to want to index those. The one up here in the user table, that's going to be a primary key, which is probably going to be indexed by default, but the one over here is going to be a foreign key. So you're going to need to index that if you so desire. Let's go through an example that's a little bit better. Let's say we have this website, and basically the point of the website is to send people good deals that are going on the internet. So we might send them some links to Amazon or to eBay or some Black Friday sales, whatever's going on at the time. We essentially want to kind of get some revenue share from them buying stuff. So we have like literally 5 trillion rows of emails. So we might want to consider indexing these. Well, we can actually index these as a group and index this entire thing, and this is going to make the query run at the optimum speed. This, my friend, is known as a composite index. These are going to be very important when you're making your queries because you're going to want your queries to be as fast as possible. So you might be wondering, well, if indexes are so great, why don't we just index everything? Well, indexes have their downsides too. Just like when you take a book and you change the contents of the book, you're going to have to update the index. So for databases, every time you update data, delete data, or add data, the indexes also have to be updated. Now the database does this automatically, so it's not something really super manual labor that you have to do, but it does slow things down. So you have to kind of balance. Do you want faster queries, or do you want faster inserts, faster updates, and faster deletes? It's kind of a hard challenge. So basically what you want to do is you want to get all of the indexes that you're going to need, but not any more, because literally every index is going to slow your database down more and more. That's why I've kind of given you this as a guide. If you're not entirely sure, this would be a good place to start. Make sure you have indexes on these, and anytime you're doing a specific query that you're going to be running numerous times and it's very slow, you might want to look into a composite index or just indexing whatever column you're looking for. It doesn't have to be unique to have an index. You can literally index any column. That basically wraps up our 5-video introduction to database design. There's actually some more database design topics that are really relevant to Oracle, and we're going to get into those as time goes on. But I didn't want to spend like years going over database design when we really just want to get into actually making a database and all that fun good stuff. So some things that are probably going to come up in future videos are data types. Data types are the type of the data. That was super unhelpful. Every piece of data has some sort of type. Usually if there's quotes, it says this is a string. If it's a number without quotes, such as 12, it's usually an int or numeric or something like that. So we'll just go with int for this case. So that's an integer, meaning there's no decimal point. You can also have dates and other kinds of data types, and we'll be getting into those as we start creating our tables. Another super really important thing when it comes to database design is naming conventions. Essentially what a naming convention is a rule that many people have agreed upon on how we want to name things. Now this is probably something I've neglected the most in this series so far. We haven't really talked a whole lot on proper naming conventions with Oracle. In fact, I've just been writing them basically as English, no naming conventions. But there's different kind of naming conventions you're going to come across in programming, in computer science, and database management systems. There's something known as camel case. There's Pascal. I'm not even sure how to pronounce that. There's two types of Hungarian notation. There's all caps or all lowercase, and so forth. So you can see there's tons of different ways we can style things. And this just describes one word. But if you look at Oracle as a whole, there's a lot of different things that you need to consider. And that's one very big thing that's important, because if you look at other people's code and they follow a different naming convention than you're not going to be able to read it very well. So that's why I really recommend that you figure out the most popular, the best naming convention, and follow that one. There's sometimes conflicting naming conventions, and if that's the case, you can pick the one that you like. Now, there's also a whole lot of database design when it comes to presentation. Depending on your role, you may or may not be working a lot with presentations. Basically, presentations are how we present the data to the user or to the programmer or whatever else. So this includes things such as views. Views are basically a saved select statement, kind of. There's also joins, which we talked about a little bit. You're also going to have to deal with things such as stored procedures, stored functions. I had another one, but I forget it. Security. These are all things that are going to need to be designed. Now, you might be the kind of person who manages the whole database as yourself if you're doing a project on your own, or you might just be working with one thing, like, oh, I only do the data definition language, or oh, I only do data manipulation language. That all depends, but in reality you should try to know as much as possible, so having a rough idea of all of these things is very, very good. So as you can tell, this is kind of just an intro. Hopefully guys, it was helpful. I really super appreciate you watching these videos. If you like them, please click like, subscribe, and of course, share them with all of your friends. Thank you. I'll see you guys in the next video. And I'm excited because we're finally going to be starting something new. So, prepare yourself. Hey guys, welcome back. This video is going to be an introduction to queries. And I apologize ahead of time if my audio is not the best. I'm in the process of kind of setting up a studio, so I don't have all my equipment set up right now, and this is the best I can do for now. So hopefully it's okay for you guys. I think we'll be able to get through it. So, let's dive right in. I'm an Oracle SQL developer, which is the app we use to connect and communicate to our Oracle database. And I have my subscribe database open. Now, if your window layout looks any different than mine, you can always go up to here to Window, and then reset Windows to factory settings. So what is a query exactly? Well, a query is how we get data from a database. And literally, people can have an entire career just from writing queries. So this topic is stinking huge. But we're going to start with the very basics. In fact, we're not even going to get data from a table. We're just going to start with what's known as expressions. Expressions are these things that can be evaluated to something. So think back to like math class. You might have something like 5 plus 5. Oh my goodness. Let's try this again. So you might have something like 5 plus 5, and that can be evaluated to 10. So this right here, this is an example of an expression. But we can also have expressions with other things, such as strings. So that is a string. In fact, we're going to put hello world. And essentially, we're going to try to create a hello world program, which is basically the first program you usually try to write when you start a programming language, just so you can get it set up, type something small, and get it running. So that's what we're going to do. It's going to be a little bit different than other programming languages because this is a database, but the end result is going to be pretty similar. So how do we go about telling the database that we want it to tell us hello world? Right now, we're telling it hello world, but we want it to respond. Well, the way we get data from a database is using what's known as the select keyword, and that's going to go at the beginning of your query. So now we're saying select this string, and it should give us the data back, but not quite. There's a little thing we have to do, and I'll explain that in a minute. But in most database management systems, this right here would work, but let's run it and see what happens. You can run it by pressing this button here or pressing F5. And you can see we get an error. And it's basically saying that it requires the from keyword. So where do we put the from keyword? It's actually right after the expression, so we put it right here. And what do we take this data from? Well, Oracle has this magical table. It's called dual. And this is going to allow us to basically do this, but in Oracle. So when we do this, it's going to respond with hello world. So let's run it and see how it works. And you can see the output right here, hello world. So it works. You guys just created your first hello world application. It's very, very simple. Now, I ain't trying to make Oracle sound much simpler than it is. Oracle is like a beast. It can do anything. In fact, it can even do addition. So instead of putting a string here, we can pass in some addition. Let's run this. There we go. 5 plus 5 equals 10. You can also throw things in here known as functions. So a good one we can try is sys timestamp. Let's try that. And you can see it gives us the exact time of our machine. So that's pretty sweet. When you're working with select statements and tables, usually you're going to want to have multiple columns. So in this situation, all we're doing is selecting one thing, but I want to select multiple things. So the way you do that is you just add a comma, and then you say the next thing you want to grab. So we could throw in a string here, say hello world, and then we could throw in another comma, and we'll actually do another math problem. Let's go 5 times 5. Now the last one does not require a comma, so you can keep it that way. So let's try this and see if it works. So we basically have a generated table. Here are the column headers, and here are the values. Although we only scratched the bare surface of the select statement, I think that's a good place to end for now. And in the next video, we'll begin dissecting this and learning a little bit more about how we structure our SQL. So thanks guys, please be sure to subscribe. I really appreciate that, and if you like this video, please click like, and I will see you in the next video. Peace! You thought I wasn't going to say it. Yo, yo, yo! Welcome back, everybody. This video, I'm going to be breaking down this statement a little bit, just to kind of explain some of the rules when we write queries, so that way you guys can intuitively know what to do with, like, this capitalization and all of that stuff. So the first thing I wanted to point out is white space. So here's an example of white space. It's a space. You need to know that Oracle is not white space sensitive. What that means is we can literally just sprinkle white space basically wherever we want, and things are still going to work the way we want. So for example, if I'm like, hey, this looks stupid, let's put like 40 spaces here. You're welcome to do that. And just to prove to you that I'm not lying, let's run this thing and see how it works. And you can see output's the same exact thing. Now there's one gotcha to this, and that's when it comes to strings. So you see here, we have a string of hello world. And anytime we have a string surrounded by these single quotes, Oracle does care about white space. So right here I have a space. If I have 2 spaces here, it's going to change the response from Oracle. Let's run it. And you can see here it actually outputs an extra space. So spaces inside of strings can change the output. So you need to be aware of that. The other thing that you need to know is that you can't separate keywords. So this is a keyword, right? And you can put as many spaces after it and before it as you like, but you can't put spaces between it, or it no longer remains a keyword. And then you're not going to be able to run your script. Boom. Error. Alright, so let's put this all back how it was. There are two other forms of white space, and that includes the tab, and also the new line. So this should still work. Yep, works fine. So I'm going to put that back. Now the next thing you might have noticed when you first looked at this is like, what in the heck is going on with all this random capitalization? Like, how are you supposed to know what's capital? Like, this is capital, but this string here isn't capital. What's going on with that? Well, this is a convention. And the convention is that whenever we have a keyword, we're going to put that in all capital letters. So this is a keyword. This is another keyword. This string here, though, that is data that I put myself, so it's not a keyword. We can keep that lowercase. And once again, this is purely a convention. So that means I can actually change this. I could say select in lowercase, run the thing, and guess what? It works just the same. This rule actually still applies when we're talking about objects we create in our database. For example, tables. Here we have a table, dual. We can change the capitalization of this, and it should still work. I'm going to capitalize every other letter, because that makes me cool. Right, so now let's run this and prove to you that it works. It works. So, I guess this brings up the question, should you follow the naming convention? The answer is yes. Literally, almost everybody follows the convention of capitalizing the keywords. And that's not just for Oracle database, but SQL Server, MySQL, and many other database management systems. So I it's a tongue twister, highly recommend that you follow the naming conventions. This too has the gotcha with the string, because the string is basically whatever data we want it to be. So if I make this all caps, when I output it, it's going to be all caps. So it pays attention to that. So you can see down here, it's outputted in all caps. So to show this a little bit better, let's write a more complex query that is going to prove that when you have a string, one of them being uppercase and one being lowercase, they are not considered the same thing. So let's go down a line, and what we're going to do is we're going to select a string, and we'll just make it say true. And where are we going to select this from? You guessed it. We're going to select it from dual. But now we're going to add another keyword in here, and that's the where keyword. And this is where we can put some kind of restriction or qualification on what the data needs to meet in order to be returned. So if you had a table that had bills, for example, you could return all of them that were greater than $500, for example. But in this situation, we're going to do something a little bit different. We're going to make a string, and we're going to put in here caps. And you can see the first letter is capital. And then we're going to see if that's equal to caps. Same exact capitalization, same exact spelling. So this is a comparison. Keep that in mind because in some programming languages, they will have two equal signs. But here we just want one. There is not any kind of assigning going on here if you guys have practice with other programming languages. So what exactly is this entire thing going to do? It's going to return the string true where caps equals caps. And when is that? All of the time. So this is literally just going to output the string true. But this brings up another good question. How can we run just this section? There's some things barking. I'm gonna see if I can shut them up. Quiet! No, I think I just made it worse. So let's output this. So to run just this, we can highlight it, and then we can run it now. And you can see it returns true. And literally it just outputted this string. Yes?
What's going on?
Oh, I'm just making a video.
What are you yelling at?
I was trying to shut those things up. It didn't work. But now let's change one of these strings to lowercase caps. And now let's run the thing. And just to make it clear, I'm going to clear this out and then run it. Wow, no rows selected. It's broken. Ha. Yeah, so you guys get it. So this is not the same as this. Now another way, rather than having to highlight everything and then clicking one of these buttons, there's something known as comments. And comments can be used to kind of tell the database engine to ignore certain parts of our code. So right now I'm not using this line, so I can tell it, hey, ignore this. And the way you do that is with two minus signs. And you can see it changes colors. It's pretty. Yeah, so now I don't have to highlight this. I can just press this button and you can see it runs. That's one type of comment. Another type of comment is known as a multi-line comment. And the way you do that is with a / asterisk / and then anything between these is commented out. So if I wanted to comment out this entire section, all I'd have to do is throw it inside one of these comments. So I could go like this and paste that up here. And then I could work on this one over here. So there. Now you guys understand spacing, capitalization, and comments. I think that's enough for this video. Let's move on, and I think the next thing we're going to do is start creating a table. So that's going to be pretty exciting, so be there or be square. And also, if you like these videos, do me a favor and subscribe and share them with all of your friends. Thank you, and I'll see you in the next video. Hey guys, welcome back to your Oracle SQL tutorial series. And I have a story for you. Well, I have been planning these videos for quite a while now, and I have been planning to record them tonight, and my family decides to watch a movie. So if you hear a bunch of people having fun in the background without me, I apologize. But it's okay, I'm not bitter or anything. Well, let's get started. This video is going to be about creating tables. And the way we do that is we use the create table command. Create table. After the table keyword, we give the table a name. So we're going to say users, because we're going to create a table where we can store people's names, usernames, and all of that good stuff. After this, you put parentheses. Inside of these parentheses is where you're going to put all of the columns that we want inside of this table. The columns are just the headers, so the first name would be a column and so forth. So the way my brain works is I like to do things in sections. So rather than doing one column at a time, I kind of do the name as a group, and then I do the data type as a group, and so forth. So what I'm going to do is just put all of the columns we hope to store in this table, and we're just going to give them a name. So the first thing I would say is a user ID. This is going to be the primary key once we get that far. And then on the next line, I will give the person a username. Following that, I will put first name and last name. Now this is not valid as is, but I did it this way so that way I know exactly what columns I need to put in this table. But we're not done, because every single column needs a data type. Data types are basically the kind of data that we store inside of this column. And there's a bunch of different data types, and it's a very extensive topic. But for this video, we're just going to focus on two very important data types that we're going to need to know to start working with Oracle. The first one is number. Number is often used for primary keys and generated numbers. The next data type is what's known as varchar, and that stands for variable character, I believe. Basically, it means a sequence of characters that varies in length. So, if I go down here and make a comment, within here I could put a string, such as Caleb Curry. I could make that my username. And I could also make it Caleb Curry, or Caleb Curry. The length varies. But what we do need to do is tell Oracle a max. So to do that, let me get rid of this. Come up here, and within parentheses, we can say how long we want to allow the string to be. So we'll put 50 in there. And we're also going to do that for the rest of them. Now, there's something weird about this data type, in that it actually ends in a 2. So you got to remember to put a 2 after the data type name. You may be able to work with varchar without the 2, but from what I've read, it's really recommended that you use the 2. And if you want to do some more research on that, I would encourage that. Now, I have a question for you guys. What does this 50 mean? Yes, I know it means how long the string can be, but 50 what? Is that 50 words, 50 characters, 50 bytes? Well, that's something we should actually tell Oracle. So after the 50, I'm going to say char, which means 50 characters. So that includes anything from a space to a letter to a number. In this situation, we would have 1, 2, 3, 4 characters. If you don't specify char there, it actually defaults to bytes. And a character can take up multiple bytes. So I always like to use char. We're going to add those into the other ones too. Now you can see we're getting some kind of error here. And the reason that is because when we have multiple columns, we have to tell Oracle where the different columns are separated. And the way we do that is with a comma. So when you put a comma, you're telling Oracle, I'm going to give you another column. So we do that for all of the columns except the last one, because the last one doesn't have a column coming after it. This here is a very good start, but it's really missing a lot of information. For example, how do we tell Oracle which column we want to be the primary key? What if we want to give it some indexes? There's just a lot of things missing in this create table statement. That being said, I don't want to overwhelm you guys with a bunch of new information all in one video, so we're going to break all that information up over a couple videos and just continually add to this and make our database bigger. One thing that you really need to try to take away from this video is to remember that the varchar data type ends in a 2. I know, it's stupid. Why would they end it in a 2? I don't know. Just a random 2. It's so dumb. Well, thanks guys. Once again, this is Caleb from Caleb the Video Maker 2. Thank you for watching, and I'll see you in the next video. Hey, what's up? It's Caleb from Caleb the Video Maker 2 in my spanking new attire. Hey boy, how are you? I know you guys are dying to know what we're going to talk about in this video. Well, we're going to talk about the details of Oracle constraints. I know we've spoken of constraints, but we haven't actually gone into detail of what the keywords are to make constraints. And we only really talked about foreign key constraints and a couple other things. So this video, drop my chalk. Oh, I got chalk on my brand new shirt. The goal of this video is to go over most of the constraints you're going to run into when you're working with Oracle Database. So what is a constraint? A constraint is basically a rule of what data we allow in a column. Another way to think about it is it forces the database to work or allow certain things. So foreign key constraints force a column to reference a row of another table or of the same table. There's also other kinds of constraints though, not just foreign key constraints, although that is one type of constraint. The first constraint is not null. This is when you command a column to always require a value. A null is the absence of a value. And something that kind of bugs me is when people say a null value, because it's like saying a nothing something. What? The second on the list is primary key. But you better not forget about that foreign key. Now these two, you kind of get how they work because we've talked about it. I swear, my dog is silent all day until I make a video, and then he's just like all over everything. You kind of already get how these work, but these are keywords you're going to have to use to tell Oracle that, hey, this is a primary key, or hey, this is a foreign key. The next constraint is called a check constraint. And if you haven't heard of this one, you should really check it out. There is another one we're going to talk about, and that's the unique constraint. Now another keyword you're going to run into, and I don't think this is technically a constraint, but I'm going to write it anyways. It's default. Now all of these should be in uppercase, but I didn't realize I was writing them in lowercase until I was already like here, and by then it was too much to have to rewrite. Now we're going to go through some of these and talk about some details so that way you know what each one of these means. We discussed not null, and unique should be pretty obvious. When you put unique on a column, it's saying that every single row has to have a unique value. So you couldn't have one row with a value 5 and then another row with a value 5. That would not work out. Primary key is essentially the combination of not null and unique. That's because a primary key always needs to be unique so we can uniquely identify that row, and it always needs to have a value. Another thing for the primary key is that it shouldn't change. If you can design your database that way, that is a huge plus. The foreign key constraint tells the database that every value in this column has to match a value of another column. Oftentimes, the foreign key is going to reference the primary key, meaning every single row in that column has to have a value that exists in another table's primary key, or that table's primary key. So if you have this table and we have a couple values in it, such as 5, 6, 7, 8, and over here we have another table, and we need to put data into this, but we label the column as a foreign key, that means the value 5 would be acceptable, 6, 7, and 8 would be acceptable, but if you put something like 10, that's unacceptable. That's because this value doesn't exist in the column that we're referencing. This would likely be the primary key, and this would be the foreign key that you would tell it to reference this column. Now moving on to the check constraint. This one is actually really super cool, and I'm excited to get into this one in more detail in future videos. The check constraint allows us to restrict more specifically on what data we allow or don't allow. Think of it like this. The unique says, hey, they all have to be different. The not null says everything has to have a value. But what if we want to be more specific, like the value has to be between 10 and 100? That is where a check constraint might be useful for you, because you can say things like that. Essentially, we're going to give it a Boolean expression. A Boolean expression always evaluates true or false. An example of this is if you had a banking application, you could make a minimum transaction, right? So let's say you're allowed to transfer money from account to account, but you have to do at least $5 or $1, it doesn't really matter, and no more than $1,000. So you could say something like between 1 and 1,000. And then you have to say what column, so you could say something like transfer amount. So I kind of running out of space there. But this is a Boolean expression. Is the transfer amount between 1 and 1,000? The options are yes, and if that's the case, it'd be true, and the data would be inserted. Or it could be no, which is false, and that's just not going to work out for you. Now the default keyword can be used very similarly. To continue on with our banking application, you could have it so when you create an account, the default balance of that account is 0. Now that you kind of get a gist of what all these do, how do you actually implement these in a database? Well, that's what we're going to start diving into in the upcoming videos, so be sure to check those out. Hopefully you guys are enjoying the series. It's a lot of fun for me. I'm really enjoying it, so please stick along and be sure to subscribe and, like all the videos and all those good things. It means a lot to me. So thank you, and I'll see you in the next one. Hey, welcome back everyone to your Oracle SQL Developer tutorial. And where we left off in the last Oracle SQL Developer tutorial was we were creating a table. And we basically set up this structure, but we haven't done anything with it. Just to prove to you that it works, let's run it. Oh, I actually didn't run that ahead of time, so I was hoping it would work. Okay, so it's created, but let's say you want to go back here and, change something. Maybe you want this to be called user_name. Well, this is going to cause an issue, because when we run it, it says, oh, this already is used. So how do you get around that? Well, as you get into some more advanced SQL commands, you can actually edit tables that already exist. That's probably the recommended way once you really get into things, but when you're just learning, you can actually just delete this table and then create a new one. So to do that, I'm going to go up here and space this down. I'm going to use the command drop table and then put the table's name. Now, please don't try this at work. Okay, let's run it. Alright, so looking down here at our results, we see table users dropped, table users created. So you can see I actually ran 2 commands at once. And the way I did that was using this semicolon. This is known as a delimiter. It's the way we tell Oracle that what comes before it is a command and what comes after it is a command. If we had more commands, we could put a delimiter here and keep writing. Come on, of all times. Now that we have the ability to drop the table and re-add it, we can reconsider the table structure. Now, once you actually have data in your table, you're not going to want to do this because it's going to delete all the data and start you fresh. But for now, since we're just learning, it's totally okay. The rest of this video is going to focus on constraints, and just for simplicity's sake, I'm going to get rid of some of these columns just so we can focus on what's really important. So right now we're just creating a table with one column, and all it is a user ID with the data type number. Now if we want to add a constraint to this, we can just put a space and then put whatever the constraint name is. So we could say not null. That is an example of a constraint, and that one is going to force every single row to have a value for the user ID. But what if you want to add another constraint? For example, what if we want to make this user ID unique? Well, it's simple. You just put a space and you put unique. And there's actually not even any kind of order that you have to put these in. You could make it unique, not null. That's totally up to you. Now, when you throw constraints in after the column like this, a lot of people call these attributes. So these are attributes of the column. And in this situation, we are applying the not null and the unique attribute to the user ID. Well, this might be a good candidate for a primary key, because primary keys are always not null and they're always unique. So if we didn't want to do it this way, we could make it a primary key. But just let's try it and make sure it works. And you can see no errors are thrown. It works great. And we can go over here to our database, open it, click tables, scroll down to find our table. Ignore all these random tables that I was working with. Double click users, and you can see that we're forcing it to not be null, and it has to be unique. So that's kind of a way you can look at a table and see what constraints they have. Let's go back though. Instead of having the not null and unique constraint, I'm going to make this a primary key. And it's super easy. All you gotta do is say primary key. That's it. There we go. There's another attribute you might want to use for some columns. That's default. Now, I'm not going to give the primary key a default because primary keys, by definition, are all supposed to be unique. So if we defaulted to a value like 12, that would be stupid because then multiple rows would be trying to insert the value 12. So we're going to create a new column. I'm going to name this account balance. And you can just imagine this being for some kind of website that you have to pay money or something. It doesn't really matter. And we're going to make this a number as well. And then we're going to set a default to 0. So by default, the person has no money in their account. This is a good column to add the default attribute to. And you can see when we run this, it should work. Awesome. I confess, as I was studying constraints, I went to the Oracle Docs page, and I noticed that default is not one of the constraints listed here. And if you go back to this and go to your table and do a refresh, it doesn't show up as a constraint either. I'm not entirely sure why, because it seems to work the same way. My first guess is that it's not a constraint because it doesn't actually prevent you from putting any certain kind of data in. All it does is help you put data in case there's no data put in, if that makes any sense at all. But I'm not sure, so if anybody knows, maybe you could shed some light on that and let me know in the comments. What we've done in this video is actually really cool, but some people like to name their constraints. They want to be able to reference a specific constraint by name. Now, when you do this, you actually get a default name. If you go back to this table here, you can see that this is the constraint name, but that's not very user-friendly. So you can actually give it a name yourself. With the way we have things set up here, we can't do that. So in the next video, I'm going to be teaching you how to create named constraints. Be sure to check that out, and if you love these videos, please be sure to subscribe and share them with everybody in the entire world. Thanks guys, and I'll see you in the next one. What's up everyone, welcome back to your Oracle SQL tutorial series. In the last video we talked about constraints, and I kind of gave you the simplified, easy version. It only takes a couple keywords, but it has its downsides. And one of the biggest downsides is that with that method you can't name your constraints. And a lot of people like to name their constraints, that way they can refer to them by name. So that's one goal of this video. The other goal is just to kind of think through the different ways of creating constraints. Because when you make them, it seems like there's so many different ways to do it. I'm going to piece it out very simple so that way you can know exactly what the different options are. Yeah, I just got a $5 donation. Veronica, you are very sweet. I really appreciate it. We are going to start with a create table statement that looks a little something like this. So we have a table users and it has a column user ID and a data type of number. Now this doesn't actually have any constraints here, but we want to create a primary key. So the way you did that in the previous videos is you just add the keyword right after. Primary key. Pretty simple. So this is what it would look like. Now if you want to name the constraint, you have to type 2 extra words. I know, it's crazy. I can't believe they're asking that much of us. So within here, you're going to write constraint and then you're going to give it a name. So it'll look a little something like this. And we'll give it a name of users underscore PK for primary key. And I'm just going to continue this line on the next line. Yes, guys, I know my handwriting has not gotten any better over the course of these years. Probably never will be. So as you can see, it's basically the exact same thing, except it's totally different. You have these 2 new words here, constraint, and then the title or the name of the constraint. So far, we've learned 2 different ways to make constraints. These were both made at the column level. That means right after the column. And we had 2 different possibilities, one named and one unnamed. The other possibility is actually not at the column level, it's at the table level. And what that means is we basically take this entire constraint and put it in the table as if it was its own column. Now it's not actually its own column, but syntactically that's the way it looks like. We put user ID, number, comma, and then we put the constraint on a new line. So you can say that is created at the table level. I really recommend you take a look at this and memorize it so that way you can kind of understand 3 main different ways of creating constraints. From simple to complex, this is the easiest, unnamed, then this is medium, and then table level is the most complex. But a lot of people like to do it at the table level, so it really just depends on what you prefer and if you work for a company, what they prefer. So to do this, it's really simple. All you gotta do is take the command you have, bring it, you don't have to bring it down to the next line. Theoretically, we could just put a comma here since white space doesn't really matter. And then put parentheses after it. And you have to say what column you want this primary key to be on. Because we moved it down to the table level, it's no longer associated with one column. So we have to tell it so that way it knows. Because we can't just say, hey, make a primary key, and it's just supposed to know which column we want it to be on. So this is how you do it with a primary key. With different constraints, it's going to be slightly different, but you guys get the big picture of how there's mainly 3 different ways you can do things. So that's it, guys. We've broken through the conceptual gap that's needed to really write good constraints. In the next video, we are going to make a named constraint for our user table. That's going to be sweet, so we're going to get some more programming experience or databasing experience, whatever you want to call it. And that's just going to be fun, so if you really enjoy this series, please go on to the next video, click like, subscribe, share it with your friends, and all that good stuff. Thanks, guys. Really appreciate it, and I'll see you in the next one. Hey, welcome back, everyone, to your Oracle SQL tutorial series. This video, we are going to be talking a bit more about constraints, but I'm going to try and be a little bit more specific and a little bit more practical by actually applying these to a real table. So we already have this users table down here with a user ID column and a username column. And just for fun, we're going to go over the SQL to create this table. So we start with a create table command, and then we give it a name, and then inside of parentheses is where we put the columns. So we have a user ID, which is of data type number, and then we have a username, which is of type varchar2, and it has a total of 50 characters. So literally, we just created a table in like 20 seconds. Now, if you already have this table created, you're going to need to remember to run the drop table command. And what that's going to do is delete the table and all of the data in it. So be careful with this command. But for us, it's fine because we're just learning. So let's run this and see if it works. And it says table users created. But the problem is here, we literally don't have any constraints on this table, which that's bad. So let's go in and add some. We'll start with the username. We're going to add the constraint not null and also unique. And usually that's fine for those just adding them in as attributes. It's when we get to the primary key and foreign key when people start to be a little bit more picky. And specifically, we often want to name our constraints. So we'll start without naming our constraint. And the way you do that is just saying primary key right after the column. This will work, but when we create this, and let's go to our table, do a refresh, and we'll go to constraints. Oh, it's gross. Look at those names. Oh, it makes me want to puke. That is just hideous. We do not want that. So to name our constraints, all you have to do is add the constraint keyword here and then give it a name. And by convention, we'll name it the table name and then underscore PK. Okay, so you can see here, there's the user's PK constraint. That is beautiful. Now there's a third way to do this, and usually this is the preferred way, and that's to add all of the constraints at the end of the table almost as if they're their own column. So the way you do that is just take all of this, and then you can just cut that, come down here, and literally add it as if it's its own column, but then inside of parentheses after primary key, you have to say what column you're talking about. That is the most complex way of adding a primary key, but often that's the way people want to do it. It's really up to you guys, but that's what I'm going to go for in this video. So let's run that and see how it works. So that was a quick rundown on how to add a primary key. In future videos, we'll get on to foreign keys, but for now, primary keys will do. So thanks guys, please be sure to subscribe and click like, and I will see you in the next video. Yo, what's up everyone? Welcome back to your Oracle SQL tutorial series. This video, we are going to be talking more about foreign keys. Now I know we've discussed these a lot, but I really want to make sure we really grasp how to design these, and I also want to introduce a new topic to you guys, which is known as parent-child relationships. So that's the goal of this video. Hopefully by the end, we'll understand foreign keys, and hey, maybe they won't be so foreign after all. So as a reminder, a foreign key is just a column that forces every row to have a value for that column that matches a value in a different column. Often these will point to a primary key, but they can also point to a unique constraint column. So to best walk you through this content, we're going to think of a little example. We've been using a user table a lot just because it's really easy to conceptualize. Essentially, it's a table that stores information about different user accounts. And let's say we're building some kind of platform where people can make service requests. Now, what the heck is a service request? Doesn't really matter. Let's just pretend like it's for a software company, and if something's not working right, they can make a service request. That means we're going to have some kind of structure that looks like a table here for users and then a table here for service requests. And you can think of these as blueprints. These are kind of the formula on how to create instances. So the table has columns, and when you create an instance, you have to provide a value for each one of those columns. So an instance is essentially a row within a column. Now with foreign keys, if you have a row, like a service request, and it points to a user who created that service request, that's a great example of a foreign key. So just for clarity, I'm going to write the tables in here. What this all means is that a particular service request, it'll have something like a user ID column, and that column has to have a value that exists in the user's user ID table. Essentially, the service request needs a creator. That means it has to be someone in the user table. That's all that means. So what should we use for the foreign key? Well, it has to be either the primary key or a unique constraint. So just for fun, let's use a username. So let's say this is a system where every account gets a username, and that column has a unique constraint. So then we have a user, and we'll just give them a super mature, nice username. YOLO Swagman. So if we had a service request, and it had a username that referenced the users table, that user would have to exist. So we could have YOLO Swagman in here. And this would point to this username. This is the perfect example of a parent-child relationship. The foreign key is the child, and what it references is the parent. It's often helpful to draw this in like a up-to-down illustration. Here's the parent, and here are the children. Oh, how cute! What a family tree that is. So these are all service requests, and this is the user. And we're talking about specific instances. So this would be like YOLO Swag, and this would be his 3 service requests. Now, I have a question for you. Looking at this picture, does the username column of the service requests table have to be labeled unique? I'll give you a second to think about it. All right, seconds up. The answer is no. That would not make sense because that means we could only have one child per parent. And in this picture, that's not the case. These would all reference YOLO Swagman. That wouldn't make sense in this situation. Now we can do that if we want. If we did do that, we would only allow one service request. I have another question for you. Do children automatically have the not null column attribute for the foreign key? Think about it for just a moment. Okay, time's up. The answer is also no. Essentially what that means is that we could have an orphaned child. I know, it's sad, but that's how databases work. So in this situation, we have a service request from nobody. Nobody made this service request. In this application, this does not make sense. Any service request would need someone to post that service request. So even though we can have orphaned children, doesn't necessarily mean we should. We don't want to in this situation. So for that column, we have to think about what attributes we want to apply to that column. What constraints does it need? Well, we don't want it to be unique, but we do want it to be not null, because that means every single one has to have a parent. This seems very conceptual and maybe not super practical, but this actually does come in a lot. For example, if you try to break the rules of foreign keys, Oracle might yell at you and tell you, you're trying to make a child to a parent that doesn't exist or something. I don't know like the exact words they use, but this will come up. All you gotta really remember is that the foreign key is the child. And I always try to think of it in this family tree kind of way, so it goes along with the whole family idea. But if you have a better way of thinking about it, go for it. It's all about what works best for you. So now we got the concepts down, let's apply this stuff practically in the upcoming videos. Thanks guys, please be sure to subscribe. I really, really appreciate that. See you guys in the next video, and don't forget to click like. Ahoy there, everyone! Welcome to your Oracle SQL tutorial series. This video, we are going to start designing a what's the goal of this video again? In this video, we are going to be designing a miniature database with the primary goal of applying what we know about foreign keys and how to design them. So we're going to start with, this is a simple thing, 3 tables, and we'll make some connections with some foreign keys, and we'll go from there. So what is the goal of our application? This database is going to power an application where people can create an account, sign in, and then they can make projects. So this is like a project management software. Imagine like Jira, if you know what that is. Essentially, you create an account, you make projects, and then you add people to those projects. So that's all it's going to do for now. So we're going to put the projects on this side. And we'll put the users over here. Can you guess what goes here? Yeah, it's going to be an intermediary table between projects and users. We'll get to that in a minute. First, let's talk about the projects table. This is just going to have information about the project, including a project ID, a reference to the user that created it, all that good stuff. And the way I'm going to be designing this is following the ERD pattern, which stands for Entity Relationship Diagram. Essentially, what that fancy word means is we're going to make tables as boxes, and we're going to list the columns down this way. And we basically just ignore rows. We're not going to care about what data is put in, because as long as we put the column and what's allowed, that's all that matters. So in the user table, we'll have a user ID, a username, first name, and last name. I'm not going to worry about data types for now. All you need to know is that if you have a foreign key, it needs to match the data type of the column it references. Now over here on projects, we'll have a project ID. We'll have a creator, which is a reference to the user. Now, this brings up the question, do we reference the ID or do we reference the username, I think? Yeah, do we reference the ID or the username? And it's ultimately up to you. I think it's kind of important to get experience with both referencing primary keys and referencing things that just have the unique constraint. So for now, I'm going to use the username, and I think that's going to improve our readability. But as we go on, I think what we choose will change. I'm just trying to get us all familiar with everything here. So creator is going to reference username. We'll also have a project title. And if I wanted to get real fancy, you could put in like a creation date and all kinds of junk like that. But that's really good for now. Now, what about this table? Well, the only other table we need is a table that lists what users are part of what projects. And that is a many-to-many relationship. That's because we designed it that way. A lot of this stuff you get to choose. For example, in this situation, a project can only have one creator. That's because it's a column inside of the table. If we wanted to where a project can have multiple creators, we would need to take that out into a separate table and name it like project creators, for example. But when it comes to the users that can join a project, I'm making that a many-to-many relationship. So what that means is one user can join multiple projects, and an individual project can have multiple users. The way we design that in database design is using two one-to-many relationships. That calls for an intermediary table. Now the intermediary table name, by convention, is just a combination of this table and this table. So you can pick one to be singular and the other one's going to be plural. So we could have project users or we could have user projects. I think it makes more sense to have project users. So that's what I'm going to go with. And this is going to have two columns, a project ID and a user ID. And these are both going to be foreign keys. Now you see in this situation, I decided not to use the username, but I could have if I wanted to. In fact, I could have used the project title here instead of the project ID. But then that gives you the limitation of that they have to be unique. Now let's figure out which tables are the parents and which ones are the children. The users table is going to be the parent. That's because it has no foreign keys. You see all the arrows point to the users table. Now the projects, that's the child of the users because you see it references the username. Now the project users table, that's a child of both of these tables. So I guess if you had to draw it out, you'd have this being the users table, this being the projects table. That's a child of the users, and then we'd have project users down here, which is a child of both of them. The next thing we want to do is ask the important questions about the foreign keys. Let's look at all the foreign keys we have here. We have 1, 2, 3. So we need to ask at least 2 questions for each one of these. So let's start with the users table and kind of move down the family tree. So we'll go to its child and we'll start at the projects. And we'll look at this foreign key, creator. Should it be unique? The best way to think about this is to ask, what would it be like if it was unique and what would it be like if it was not unique? If it's unique, that means within our table, we have a column and it's a creator. We can only reference a specific creator one time. So if it's 7, that means that's the only time that creator can be in the projects table. Personally, I don't think that's a great idea because essentially what that is saying is that a person can only create one project. That's up to your business decisions on whether that's a true statement or not. But in this situation, I'm going to make it to where a user can create multiple projects. So it's not going to be unique. Now, is it going to be not null? Well, if it is null, that means a project can exist without a creator. And I don't think that makes a whole lot of sense. So I'm going to say not null. And we can look at these IDs, and if you want, you can go through the whole process. But I've come to the conclusion that this is going to be the same for all of the foreign keys here. Because we're not going to want to make it to where a person can only join one project, or a project can only have one user. This stuff doesn't make sense. And it also doesn't make sense to have a project with no user inside of the project users table. So obviously you want it to be not null. Hopefully that wasn't a little too quick for you guys, but hopefully you guys get the point, and just it's really important to really think through this stuff. Like, a lot of effort can be saved now by working harder on the design and the engineering of the entire solution rather than rushing through it and just pooping on a database and trying to get out good data. Structure it, and then your data is going to work out. I know it's a lot of extra steps, but it's worth it. So thanks, guys. Really appreciate everything you guys do. Thanks for watching these videos, liking them, and ultimately, I really appreciate you subscribing. Hey, welcome back everyone. This video, we are going to be starting a small project for projects. So I really highly recommend you watch the previous video, but if you're stubborn, essentially what we're gonna do is create a small database where you can have users and then projects that these users create, and then they can add users to those projects. So essentially a project management software, but very simplified. So to start off, this is the table we have. It's just a user ID, a username, and a primary key of user PK. This video, we are going to be creating another table and creating a foreign key on this table that references the users table. So to begin, we just follow the same pattern we have up there, create table, and we'll name this projects. And then open up some parentheses, and this is where we're going to put our columns. So first, let's put all the names of the columns we're going to use. I think this one will have 3 columns: a project ID, a project title, and then a creator. And the creator is going to be the column that references the users table. So let's start. Project ID, project name, and then creator. Now we need to give them data types. So I'm going to give the ID the number data type. The project, I'm going to give varchar2, and then that'll be 50 characters max. And the creator, this one actually has to match whatever we're going to reference. So if we decided we wanted to reference the user ID, we would want to make it of data type number. If we want to reference the username, we would have to make it varchar 50 characters. And that's what I'm going to go with for now. So I'm going to say varchar2, 50 char. Awesome, so we have our columns. Now we just have to worry about what constraints we want on these columns. The first one I would say is we're gonna make the project name unique, and that's just to kind of prevent confusion. That way there's not 2 projects with the same exact name. Now the creator column, that's the one where you have to think a little bit more on whether it's going to be not null or unique. And we talked a little bit about this in the previous videos. For unique, if we said unique, that means there could only be one instance of a specific creator in that table. That means one person could only create at max 1 project, and we don't want that, so we're not going to put unique. But we are going to put not null because we want to make sure every single project has a creator. Obviously, that would make sense. The next thing we're going to want to add is the primary key, of course. So let's do that by adding it as a table level constraint. And then we'll just name it projects underscore PK, primary key, and then in parentheses, we'll just put the column name, which is project ID. Also, don't freak out if you don't have all of the keywords memorized. It comes with repetition. Oh, and it's also right up here, so, I may have cheated a little. Now, the real question is, how do I tell Oracle that I want this column to reference the username column of the other table? And just like with the primary keys, there's different ways of doing this. We're going to go over all 3 so that way you get a full picture, but then you can choose whichever one works best for you. The first and the easiest is doing it at the column level, unnamed. So to do that, we're going to go to the creator column because that's the one we want to mess with. And then in here, all you have to do is say references, and then say the table you want to reference, users. There's only one problem. It doesn't know intuitively which column you want to reference. So you have to tell it inside of parentheses. So we're just going to say username. And make sure you spell it right too. So let's run this, make sure everything's right. Okay, we got an issue. What is it? I think it's because I forgot a semicolon. All right, let's try this again. There we go. We created the table. We're going to edit it though because I don't want to do our constraints that way. So for future, I'm going to add the drop table projects up here. So that way I can just continue to create the table over and over again until I get it perfect. The next way we want to learn how to create constraints is at the column level, but we want to name it. And if you remember when we made the primary key, all we did was after the primary key column was say primary key, and then we added into here, we said constraint, and we gave it a name of users underscore PK. It works very similar with foreign keys. So I'll show you. Let me get rid of this. And we'll come down here to our foreign key column right here. And we'll just add in the keyword constraint. And then we'll give it a name of projects underscore users underscore FK. And you can pick up your own naming convention, but essentially what I did here is said the original table and then the table that it's referencing, which works for now, but it is problematic. For example, if we have 2 foreign keys referencing that table, but you know, that's for another day. We'll run this, make sure it works, and you can see it was created. And we are getting some issue up here, so let's look at that. So I believe the issue is that we are referencing the users table from the projects table. So it's not going to let us drop the users table. So the trick to this is we just need to switch these around. Boom. Then we'll run that, and boom, there you go. The third way is a little bit different than the way we did with the primary key, but it's not a substantial difference. We are going to take this entire thing and we're going to cut that and put it as basically its own column in this table. But we're not going to add parentheses after the name because they're already there. We have to go back here and say what column we're starting with and telling it that it's referencing this. We also need to add the foreign key keyword. So as you can see, there's a couple differences between the two, and you're just going to have to become more familiar with them over time. I too am still learning these. And then we're going to throw in the column that we're starting with. So that would be the creator column. So let's go creator. All right, let's run this, make sure everything works, and now I didn't break anything. Okay, all the tables are created, and it seems to be working just fine. Now as for creating the table, it seems like we know our way around pretty well. But what happens when we put data inside of these tables? For example, we add a user, and then we add a project that references that specific user. And then we want to go back and delete that user. Well, now what happens to the project that references that user? That is a big thing we have to learn about, and essentially that's going to bring up the command on delete. So you can add the on delete command to our foreign keys to tell it what to do in those awkward situations when stuff like that happens. That's what we're going to be talking about in upcoming videos, so please be sure to subscribe. I think you guys will really appreciate the new content, so thank you so much, and I will see you all in the next video. Hey guys, welcome back to your Oracle SQL tutorial series. This is Caleb from Caleb the Video Maker 2, and in this video we are going to continue our discussion of foreign keys, constraints, and what they are supposed to protect us against. So the first thing constraints are supposed to protect us against is incorrect or invalid insert statements. So for example, in this users table, we have a unique constraint. So that means if you try to put a username in there that already exists, you're going to get an error. So let's just show how this works. So I already have both of these tables in existence, and we're going to run an insert statement. If this is your first time learning about inserts, congratulations. But it's really simple. All you got to do is say insert into, and then say the table. So let's say projects. And then all you do is say values, and then in parentheses, you pass in the values separated by commas. So we just have to make sure we match the data types. Numbers are always just plain, no quotes or anything like that. So we could just say 24, 23, whatever. Then a comma, and then inside of quotes, the project name. And then finally, we need to say the creator. And that's going to be the creator's username because that's what the creator column references. So that means we need to pass in the username inside of quotes. So in here, I'll just say created by Caleb Curry. And then we'll highlight this entire thing and run it. And you can see we get an error. You see it says integrity constraint violated, parent key not found. And what that is saying is that we tried to make a project and assign it a creator, but that creator does not exist. These constraints work really well at protecting us from invalid inserts. But the other thing they need to protect us from is invalid deletes. Now, how does that work? Well, by default, you're just going to get an error if you try to delete something that violates a constraint. And let's go through an example that shows this. We're going to keep this insert statement for the projects, but first we're going to create a user. Insert into users, values, and then we'll just fill in those columns. The first one, the user ID, we'll go with 1, and then we'll give them a username of Caleb Curry. Put a semicolon so we can run both of these at the same time. Hover over all of it and run it. And you can see in here, both rows were inserted. So if you wanted, you could go look in the table and see the data. So I already have the users table open. You can click data, and you can see we have user ID of 1 with the username Caleb Curry. but we don't need those for right now, so I'm just going to drag that back down. Now, let's be mischievous and delete stuff. So to do that, we need to use the delete keyword. So we're going to try to delete the parent, Caleb Curry. We need to use the from keyword, and then we need to say what table. Users. And then we need to use what's known as a where clause to specify which users we want to delete. So we'll say where, and then we'll say, let's go with the user ID equal to 1. So that's going to delete the user who has the ID of 1. Let's run it. And you can see we get an error. It says attempted to delete a parent key value that has a foreign dependency. So you can see it's not even going to let us delete the content from the table. And that's pretty good by default. But what if you want to configure some stuff? You can actually do that. And to do that, you need to use the onDelete keyword when we define our foreign key constraints. So we're done with this insert and delete, so let's just get rid of that. Let's go back to this projects table. And after the foreign key constraint, let's add the keywords onDelete. Then you need to say onDelete, what do you want it to do? The first option I'm going to explain is set null. Essentially what this is going to do, that row's creator column is going to become null. That might work in some situations. In this situation, it's not going to work super well because we have it labeled as not null. So when would you want to do that? The best time to make it set null is if the long-term survival of projects is important to you. If that user deletes his account, well, the project is still going to exist, it's just going to be creatorless. What is the other option, though? The other option is called Cascade. What this is going to do is also delete the child. And yes, this can get very dangerous because 10 years from now when you're working with your data, you try to delete something and that delete cascades through your database like a virus, deleting all kinds of stuff. So you need to be very, very careful with the onDelete cascade. In all honesty, the default is probably the safest route because it's basically going to prevent you from deleting anything, because everything's connected. But that gets really frustrating because then you always have to find the child of the child of the child and then delete up the tree until you get to the parent. So it can get a little frustrating. In this situation, we're going to go with Cascade because we want it that if the user deletes his account or he gets banned or something stupid, then the project is just deleted. We don't want it to be in existence anymore. Whether you want your app to do that, that's up to you, but that's what we're going to go with in this situation. So first, let's delete that table. So we'll hover over this and run that. And then finally, let's create that table again. So it's created. Everything seems to be working. And now when you delete the parent, that change will cascade down and delete the project. So hopefully that was useful for you guys. If you guys have any questions, be sure to leave them in the comments. I will try to help you out, or if anyone else knows the answer, I'm sure they'll try to post something. If you like these videos, please be sure to subscribe, click like, and continue watching. Thanks, guys, and I will see you in the next one. Hello, everyone. Welcome back to your Oracle SQL tutorial series. This is Caleb from Caleb the Video Maker 2. We are going to be continuing our little project that we're working on. So far, we have 2 tables created. We have a users table and a projects table. This is great and all, but it's very limiting. That's because you can only create projects, but you can't add anybody to these projects. How useful is that? Not at all. So if you go back a couple of videos, you'll find a video where we talked about the design for this project. And we were going to have a project users table. So essentially it's a table that says what users are a part of what projects. So if you're thinking of the workflow for our project, a person would create a project, invite all their friends, and then those friends or whatever could join the project and be a part of it. Or they could be assigned to it. So since I have all of these other tables, I'm just going to comment those out by going to, I don't even remember, source, toggle line comments. Now let's focus on creating that other table. So let's say create table and we'll name it project users. And what columns are going to be in this table? It's literally only going to be 2 foreign keys. So the first one is going to be the user ID, and then the second one is going to be the project ID. Now in the previous videos, I talked about naming the constraints, but we're actually going to put a giant primary key on top of both of these combined. So I'm going to be a sinner for a moment, and I'm not going to name these, but don't tell anyone. It's a secret. So to do that, we're just going to say references, and it's going to reference the users table, and the column it's going to reference is the user ID column. Beautiful. We'll do the same for the project ID, but it's going to reference the projects table and the project ID. And I should probably learn how to spell references. I thought I got an A in spelling one time, but then I realized that A is actually an F, which makes sense why I got that grade. Okay, sorry, that was really, really lame. So here we have our extremely unprofessional, unnamed foreign keys. But now we're going to add a primary key on top of these. But we're going to do that at the table level, so that way we can, make up for our unprofessionality. So to do this, we need to use the constraint keyword. And now we're just going to name it the convention we've been using, the table name followed by an underscore followed by PK. So it'll be project underscore users underscore PK. We need to say that it's a primary key, and then we need to say what column that primary key is on. Now, this is one of the benefits of using table level constraints because you can actually pass in multiple columns here. So the first one, it can be user ID, and then the second one can be project ID. And what that is saying is that the combination of these have to be unique. So multiple rows can repeat the user ID, for example, and multiple rows can repeat the project ID, but the combination has to be unique. This is also going to index the combination of these columns. So we're getting like two great things in one line. Wow. So let's run this command, see if it works. Okay, there's something broken, and I forgot to add a comma right here. So always remember when you add the constraint at the table level, you need to throw it in there as if it's another column and add a comma to the previous columns. Let's give this another try. Okay, you can see down here that the table was created. So we got this table created. It's nice, it's beautiful, but the thing is, if we ever try to delete a user or a project, Oracle is just going to bark at us and tell us, no, it ain't happening, man. That's because by default, when you try to delete a parent that is being referenced by a foreign key, it's going to throw an error. And what that means is we need to add the onDelete keyword. So to do that, we need to go over here and say onDelete, and I think I'm going to use cascade. And while I'm at it, I'm also going to add the constraint not null. That's because there should always be a value for this column. Same for the project ID. And onDelete, we'll make this one cascade too. Essentially what that means is if a user gets deleted, it's going to delete all of the rows in this table that reference that user. And the same for projects. If a project's deleted, it'll delete all the projects in this table that reference that project. And you can see how this gets pretty dangerous when you're always cascading things because it'll just delete everything, as I mentioned in the previous video. So please be careful with this. So before we can rerun this command, we're going to have to drop the table. So we'll say drop table project users. Add a semicolon, and we can just run it. All right, so you can see the table was created. Now real quick, let's insert some data and see what happens when we delete things. I'm gonna write out the SQL and you can copy it if you want. That's because I don't really want to distract from the purpose of this video. So first off, I was messing around with this, and to clear out the tables, I run these commands. But we're not gonna need those for now, so I'm just gonna get rid of those. The first thing, we're going to insert two people into the users table. We're going to insert a project, and then we're going to insert a project user. So we'll start with the first one and we'll just run these one at a time. So we got that row inserted, got that row inserted. All right, so this one caused an error. What's up? Oh yeah, that's because we referenced the username, not the ID. So I need to pass in the username here as Caleb Curry. There we go, we got that one. And finally, let's create a project user. Okay, we also got an issue here. Let's see what this is about. Oh, that's because I put the columns in user ID, project ID. I'm going to flip those just to make things a little bit more clear. It makes more sense to have project user since the table's project users. We'll need to drop that table and then recreate it. So let's try this again. Oh, finally, we got that working. Now, if you want to actually see that data, you can run these select statements. And I'll extend this so you can see everything. So here's the first table, the user table, the project table, and then the project users table. And now, the moment we've all been waiting for. Let's delete a project and see what happens. Done, done, done. Oh, there's an error. Okay, let's add the project underscore there. Totally didn't make that mistake. Done, done, done. One row deleted. No errors. But now if we go back to this project users table, let's run this command. And you can see there's no rows to return. So it just deleted it. Doesn't even care. So overall, we have a pretty good structure for our database. The only thing we should consider is adding some indexes. And that's what we'll be discussing in the upcoming videos. Please keep at it. Click like, subscribe, and I will see you in the next video. Welcome back, guys. In the last video and throughout this series, we've been working on this database. Essentially, we have 3 tables that allow us to have a very miniature project management database. Now, what's wrong with this database? Well, overall, I think it's pretty beautiful, but there are some things we could improve, specifically indexes. As we've spoken about before in the past, the only columns that are indexed by default are the primary key and any columns with the unique constraint. So each table here has a primary key, the user ID, the project ID, and the combination of the user ID and project ID down here. As for unique constraints, only the username and I think that's, the project name too. So those are all going to get indexed. But I also mentioned before that a column you should consider indexing is any foreign key constraints. That's because they are not indexed by default, but they're so commonly selected and used in joins that you should almost always index them. So the creator column is a foreign key that references the username up here. But the problem is it's not indexed. So this might become a bottleneck when we're doing select statements. So in this video, we're going to take that column and add an index to it. Now this is actually separate from creating the table. So we don't actually have to have all this stuff here still. So to create an index, yeah, it's pretty crazy, but we use the create index command. I never would have thought of that. And then you give it a name. We'll name it the table underscore column underscore IX for index. So we're doing this on the projects table, and we're going to grab the creator column, and we'll just use IX for index there. So we create this index, but we have to tell it what column and what table we want it to be a part of. Because this is not part of the create table statement, it's not just going to know by default which table we want to put it on. So we need to say on and then specify a little bit more information. So the first thing we want to give it is the table. So we're going to say projects. And then the next thing inside of parentheses is the column. And this is going to be on the creator column. So let's run this, see if it works, make sure I got all my syntax right. And you can see we created the index. Beautiful. Now this doesn't apply in our situation because our column is not labeled unique. But if it is labeled unique, you can actually create a unique index and you just add the keyword unique right after the create keyword. But once again, that's not needed, so I'm just gonna obliterate that. And now I'm going to move on to teaching you how to actually delete these indexes once they're made. So if you want to delete an index, it's super easy. Kind of like dropping a table, you just say drop index instead. And then you just say the name of the index. There you go. So let's run this, and you can see it'll officially delete our index. I thought giving you that little extra information might be useful in dropping the index in case you need it. But for now, I'm actually going to recreate that index so we have it. That's how you add an index to a column. Unfortunately, I still think there's a potential problem with our database design. To show you that, I'm going to go back to the create table statements and I will point it out to you. So I'm just going to undo it all. So here we are, back at our create table statements. The problem here is in the projects table. We have a creator column, and this creator column references the user's username. Well, in this situation, the username has to never change. And if you're wondering why, that's something we are going to dissect in the next video. So everyone, please be sure to go watch that video. Click like on this video and be sure to subscribe. Thanks, and I will see you in the next one. What is up, everyone? This is Caleb from Caleb the Video Maker 2, and we're going to be learning something new today. We are going to be learning why primary keys should never change. So with the database structure we've been using, we've had a user table that has a username column that is referenced by other tables. But it's important that nobody updates their username. Why is this? That's essentially what I'm going to try to answer in this video. First off, what does happen if you have a username column and someone references that as a foreign key and you try to update your username? Well, it's simple. Oracle just throws an error and doesn't let you update it. not a problem. Nothing breaks, nothing explodes, it just doesn't run. The problem in this though is that now you can't change your username. This really depends on what your application does, what its purpose is, but maybe not changing your username is a good thing. Some applications allow you to change your username, others don't. But if you're referencing that username as a foreign key, you want to design your app to where you cannot update your username because it will cause errors. For those who appreciate a visual, this is what it would look like. We have a username column that references the username column of the users table. Now, we have a user who tries to change their name. Now, some database systems have something called onUpdate, and then we could say cascade, and this works very similar to the onDelete. Essentially, if the person updates their username, the username in this table is also going to update. Unfortunately, Oracle does not have this. So there's not a real super easy way to do something like this in Oracle. That's why I'm stressing it so much that if you do this, you need to make it to where the username does not change. But just to tickle our brains a little bit, let's imagine Oracle does not care and doesn't throw any errors. Let's figure out what would happen. So in the projects table, I actually named this wrong here. The table that references the username is the creator table. The name actually doesn't matter. It doesn't have to match the column, so it's not a big deal. But let's say we have a creator, and his name is Seeker7. And that obviously has to match a user in the users table. But then Seeker7 is all like, you know what, this name's stupid. I'm gonna change it. And he changes his name to Seeker7. But this one doesn't update. Now we have the issue that we have a project created by some mysterious user who doesn't exist because there is no such thing as a Seeker7 inside of the users table. Even worse, there might be another guy who realizes this Seeker7 is the creator of this group or this project. And then he updates his username to Seeker7. And now he has admin rights to do whatever he wants in this project. See the problem there? That's why a lot of people lean on the side of using surrogate primary keys and only referencing those with foreign keys. So if we wanted to do that, all we would need to do is have a user ID, and instead of having a creator, we'd have a creator ID. And instead of having a username here, we just have a number. And then this Seeker7 with the ID of 7, he can update his name to Seeker7, but his ID still stays the same, and this connection isn't broken anymore. That is something we can do in Oracle, and this is no longer in our imaginary world where Oracle doesn't care. This actually does work. That's why you often see something like creator ID referencing another column in another table. As a rule, primary keys should never change. So don't make a primary key that's going to change. The username, if you can change it, it would not be a good primary key. The user ID is perfect because it's just an arbitrary number that the database picks. It doesn't have any real-world meaning. So primary keys never change. Now I'm going to ask you a question. Is it appropriate for foreign keys to change? I'll give you a second. The answer is yes. Why though? Well, in this situation we reference the user 7. If we were to change this, let's say to 8, the only thing now is it no longer points to this person, it points to someone else. So this is actually a good thing because it allows us to change things in our child table. So for example, if this person wanted to give off the project to someone else, he might assign some other guy as the creator, and then he could delete his account or whatever. You know, it's really flexible on how this applies, but yes, it is appropriate for foreign keys to change. But if it's talking about one person or one entity, then it should never change. So let's go back to 7, for example. In this situation, as long as we're talking about this person, this should never change. The only time this should change is if we change the entity we're talking about. So from what I've said, it seems like it's always the best idea to have foreign keys that reference an ID. But there's also a lot of downsides. If we have a project's user table, which just lists all the users in specific projects, it might look something like this. The way we would get this data is something simple like select everything asterisk from, and then put the table name, which in this case would be like project users, for example. This is super easy to get this data. But if we get rid of the foreign keys that are nice and easy to read and replace them with IDs, this is going to say something like 5, 5, 12, 83, 72, 83. And we're no longer going to have this. That means what we're going to have to do is join these with the other tables and say, where do these go? And then we're going to have to create a really complex select that has joins. So that's the biggest consequence in my eyes. So the question is, which one do you choose? Choose wisely, my friend. The ultimate decision is up to you, but please choose wisely. Thanks, guys. Please stick around for the next video. Be sure to subscribe, and I will see you next time. Hello, and welcome back to your Oracle tutorial series. Now, it has been quite a while, so let me just kind of give you a refresher of what's going on my channel. Well, I decided I'm going to make Oracle videos, MySQL videos, and SQL Server videos, and kind of turn it into a competition. And the competition starts with video 23, which is this one. So if you like Oracle, be sure to click like and watch all of these videos in this series, because the winner is going to get an extra 50 tutorials. Woo! Alright, so let's get started. What are we going to be talking about now? Well, we are going to start talking about Oracle data types. All of the data that we store in our tables has to have a data type. Now, when we create the table, we put the data type after the column name. What is a data type, though? Why do we have to put that information there? Well, put simply, just look at the name here. A data type is the type of data. Rather than just saying data, we classify it into a certain type. That way the database has a better knowledge of how to work with it, how to store it, how to optimize storage and speed, and all of those things. So by having data types, we're able to improve our database. In addition to improved performance, data types also help us reject incorrect data. For example, you might have one column that has a data type, and someone might try to insert some data into that doesn't fit that data type, and it will get rejected. By telling a database what type of data we want for a column, we're able to restrict garbage and keep that crap out of our database. Onyx, can you chew later? Chew. That's so gross. Now, to help us study databases, they are often categorized. You know, we always got to make categories. There are 3 main categories. There are some additional ones, but the 3 that I'm going to discuss with you now are the most important and the most common ones. Then the other ones are used occasionally, so we'll discuss those later. So let's start with the main 3. Numeric, string, and temporal. If you are not super familiar with these words, you could say numeric is numbered data types. String is alphanumeric, which means characters and numbers. And then temporal is time spans and dates and times. So these ones have to do with numbers, something you would do math with. String has to do with characters or a sequence of characters, so anything inside of quotes. And then anything dealing with time is temporal. Now in each one of these categories there are some different data types, so in the upcoming videos we're going to discuss those in more detail, but this video is kind of just to get you a rough overview, so when we start talking about them you're not like, what? An important thing to know is that each one of these is known as a character. So this is a 5-character string. Other examples of characters are numbers, symbols, as well as letters from other languages. So characters go inside of string data types, but numeric data types only take numbers. So these are pretty good categories, but there's one extra thing that I wanted to mention before we move on to the next video, and that has to do with storage. That's because one thing that all of the data types are going to have in common is they all take storage space. They take up space on our computer or our server, and us as database people have to figure out the best way to store these so they take up the least amount of space. I'm not going to go over all of the details on how to do that right now, but just something to kind of keep in the back of your brain is to use the amount of space that is enough to store what you need, but don't store any more than that. So for example, if you're storing a string, make the size of that string column as small as possible to store what you need. For example, if you're storing a phone number, there's no need to make the column able to store 300 characters because a phone number is only like 10 to 11 characters or something like that. You'd think it wouldn't make such a huge difference because we're talking about character data, it's not huge file sizes. But when we're talking about the difference of 1 byte across millions of rows, the difference becomes substantial. If you are unsure on how to size something, size it on the larger side of your unsurety. You wouldn't want to make it too small and then later have to figure out, oh crap, how do I change this? So yeah, aim bigger than smaller if you're unsure. That's all for this video, guys. Hopefully this next section of videos is going to be real helpful for you guys. Thank you for watching, and as always, I'll see you in the next one. Hello world, this is Caleb from Caleb the Video Maker 2. Last night I had this great idea on how I was going to grow my YouTube channel, and I could not sleep for the life of me. So I'm a little cranky today, so you better not get on my nerves. You understand me? You understand me? Okay, where was I? Data types. Now I decided I'm going to cover data types in some pretty good depth for Oracle. The reason being is that data types are foundational to creating good quality tables. In addition to that, I am trying to go in a lot of depth with this series so that way you have a more deeper understanding of Oracle and not like, you know, super shallow, I know how to create a basic table and blah blah blah. That being said, I'm not going to bore you with all of the details. If you want to know super depth, you can read the manual or get some books or something like that. My goal is to teach you concept. So I want you to understand concept in depth. Because I'm teaching you in depth, there's a chance the important stuff gets lost in the details. And because of that, I decided I was going to create this video. So this video is your shallow overview of the most important data types. Why though? Why don't we just go in each one in depth? Well, that's because I want to give you the most important ones you're going to be using, and then if you know like, oh, this is the data type I need to use, then you can go in the upcoming videos and you can learn more details about them or research it online. By the end of this video, you're not going to master data types, you are going to know the bare minimum required to create basic tables. The first data type, one we've actually already discussed, is number. Oh gosh, that was disgusting. Oh, now, number. It's used to store numbers, as you may have guessed. We have been using it to store integers. So when you have integer data or just int data, this refers to whole numbers. That means no decimals. But numbers can actually store decimals too. So number is the data type you want to use if you have whole numbers or numbers that you need very good precision with in math. For example, if you're working with finances, the chances are you are going to want to use the number data type. There are two other data types that work similarly, but they're a little bit different. And these ones are used for data that have numbers, but not numbers that have to be exact. So for example, if you're working with math of money, you want it to be exact. You don't want to gain a couple pennies or lose a couple pennies or whatever currency you're in. You want it to be exactly the number you're expecting. Well, sometimes it's not that important. For example, you might have a number 5.98734 and the farther you go this way, the less important the exactness of the number is. For example, if you're measuring the distance from here to over there and your answer is this many feet, do you really think it's going to be any different if the number turns out to be like this? The chances are probably not. That's because the difference between this and this is so small. So if you're working with that kind of data, there are two data types that'll fit your situation perfectly. Binary float and binary double. You can use either of these data types if you're in the situation where you don't need absolute exactness when you're talking about far down the fractional side of the number. What are the difference between these two though? This one is going to have more precision than the float. So if you need high precision far down, you will want to use binary double. If you don't need quite as much precision, binary float might work just fine. We'll go into the depths of how many decimal places will work for each of these and all of that in a video in the future. But just know what data types you need if you need something like this. All of this is great if you're storing numbers, but you don't always want to store numbers in a database. Sometimes you need to store string data. The first two data types we are going to cover in the string category are char and nchar. These are both what's known as fixed length data types. That means if we make a column of char that allows for 50 characters, every single value for that column is going to be 50 characters, even if you store less than 50 characters. So if you put something like hi inside of a 50 character char data type column, it's actually going to store 2 characters, 1, 2, and then 48 spaces. And you can see how that could be a bad thing. The two data types for variable length are varchar2 and nvarchar2. The difference here between the previous two data types is that these are variable length. And what that means is you could make a column varchar2 of 50 characters, and if you only store something like hi, it's only going to store 2 characters, not 50. There are a couple more data types I want to give you, but I'm not going to talk about these ones in a ton of depth. That's because there's a lot to them, and that might take another video in the future, but I will still introduce both of them to you. So I'm going to erase this and then we'll discuss those. These can both be used to store a date and time. For some database systems, date will only store the date, but for Oracle, date actually can include the time as well. As for the difference between these, I decided we'll cover that in another video, but just know if you need to store something that has to do with dates or time, you can use one of these. There's also interval data types, and this will allow you to store data like 2 weeks, so an interval of time. So once again, those are some of the most important data types you are going to come across when you're working with Oracle. Hopefully that was helpful. If you've liked this video, please click like and help the Oracle videos win the competition, because right now they're losing. Be sure to like this video and watch the next video, and I'll see you then. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. This video we are going to be talking about UTF-8 and UTF-16 for the Oracle Unicode character sets. Now these are examples of encodings. There are multiple options for Unicode character sets when it comes to the encodings. These are just 2 of them. There are a couple of other ones, but these are 2 of the most commonly used ones, especially when it comes to Oracle database. Now the very first one I'm going to be talking about is UTF-8, which is an example of a variable length encoding. What this means is that when we are determining how much room a character takes up on a computer, it depends on what character it is. An individual character, at minimum, will take up 1 byte. A bit is the smallest thing a computer can store, and a byte is 8 of those. Now, some characters are going to take up 1 byte. That's because we can only store so many characters in 8 bits. After that, the characters are going to take up 2 bytes, which means it takes 16 bits to express that character, and so forth. So it's going to go to 3 bits when it runs out of room for that, and then 4 bits. So to give like a 30-second crash course on storage, a bit has 2 states. You could say on or off, and some people will say 1 or 0. So if you have 8 bits, you would have something like this. You can see 1, 2, 3, 4, 5, 6, 7, 8. And then this can be interpreted as some character. Now, if you want to know how much storage that really is, you can compare it to some storage sizes you know of. So for example, 1,024 bytes is 1 kilobyte. 1,024 kilobytes is 1 megabyte. 1,024 megabytes is 1 gigabyte. 1,024 gigabytes is 1 terabyte. 1,024 terabytes is 1 petabyte. So when you buy a 1 terabyte hard drive, you can store a crap ton of bytes. That being said, when you have a string, it can store a lot of characters. You could put thousands of characters within a quote, and that can actually add up to a lot of space when we're talking about millions of rows. That means optimizing storage when it comes to strings is pretty important. Not so important when you're working with a small database, but when you're working with huge databases, the difference between 1 byte per character can make a ton of difference. And what I mean by 1 byte per character is that some encodings will always take 2 bytes per character. In that situation, even if you have a character where UTF would only use 1 byte, it's going to use 2 bytes. So imagine something like this. And it might not be exactly like that, but essentially we have 16 bytes, but only 8 of those are being used, and it's a waste of space. Now, if you think back to when we created a table and we had data types, we did something like this. And then inside of parentheses, we put 50 char. The reason we put char here is a little bit more clear now that we've talked about encodings. That's because some characters could take 4 bytes, for example. So if you're expecting something like 50 characters, but each character takes 1 to 4 bytes, you're not going to get 50 characters in some situations. Some situations you may if all of the characters only take up 1 byte. So for example, if you're using English, the chances are you're getting 50 bytes, but the chances are that's still going to be 50 characters. But if you're storing an Asian language, the data is not going to take up 1 byte per character, and you're not going to get 50 characters out of this. Other database management systems will always default to characters. So for example, in MySQL, you could say something like this. And in this situation, I'm not specifying char. That's because by default, this is 50 characters. But Oracle is different in that you can specify char to force 50 characters. That's because the default here is actually bytes. Okay, so moving on to UTF-16. Now UTF-16 is also a variable length encoding. The difference here is that it's variable between 2 or 4 bytes. That means if we're storing a character like A, it's still going to take up 2 bytes even if that's not needed. So UTF-16 can take up a lot more storage when we are working with English. That being said, these do not line up exactly the same, and in fact UTF-8 will usually take 3 bytes for Asian characters, whereas UTF-16 will take 2 bytes for Asian characters. So if you're working with a lot of Asian characters, UTF-16 might actually save you space. So it really depends on your situation. So that's a perk for UTF-16. But UTF-8 is what's known as a superset of ASCII. And what that means is if this was UTF-8, ASCII is right here. If you're working with an application that's using ASCII and you want to convert it to Unicode, UTF-8 is going to be your best bet because the characters of ASCII directly correlate to the characters of UTF-8. But UTF-16 works better with Java programming and Microsoft.NET. So which one are you supposed to use? Well, you just have to weigh the pros and cons and think about what situation you're using it for, and that'll help you make a decision. If you're just working with small applications, generally it doesn't really matter that much because the size differences are small unless you're dealing with a whole lot of text data. So yeah guys, that's all I have to say about Unicode for right now. Hopefully that was helpful, and in the next video we are going to be talking about char and nchar. And now that we know all this crap, it'll be a little bit easier to discuss the differences. So thank you so much everyone, I really appreciate you guys watching my videos. If you liked the video, please click like and subscribe to this channel to help me out. Thanks, I'll see you in the next one. What's up guys, welcome back to your Oracle tutorial series. This video and the upcoming videos we are going to be discussing data types in much more depth. So we're going to start with char and nchar. Specifically, this video will cover char. So char is short for character. This can hold a string of characters. And the thing about this is that it's a fixed length data type. That means every single string is going to be the same size. And if for any reason we don't give enough data to fill that whole length, it will pad it with extra spaces. So for example, if we have something like this, char 10 char, but we only pass in hello, well hello is only 5 characters. That means it's going to add 5 spaces for us. Now this keyword here, char, this is known as a qualifier. You can think of a qualifier as something that describes something. So kind of like an attribute describes an entity, this qualifier describes what this 10 means. Specifically, this is known as a length semantics qualifier. Lots of big words here, especially that one. That's funny. So what does semantics mean? Semantics describe the meaning of something. So if you wanted to put this in English, you could say that this char describes the meaning of the length. So the describes would be the qualifier, the meaning would be the semantics, and the length would obviously be the length. But if that doesn't make any sense or you just think it's a bunch of useless information, all you got to think of is that this char describes how we interpret that 10. In this situation, we are saying 10 characters. Now, if we don't put this char here, the default is actually byte. If you want, you can throw in that byte keyword. That way you can be very specific. Or a better word would be explicit. So if you explicitly do something, you are putting it there even if it's not necessarily needed. You're giving extra information. You're being very specific in what you want. But if for some reason you don't put either one, just like this, you no longer have 10 characters, but you have 10 bytes. And remember, one character can take up multiple bytes depending on the encoding. Now, if the default is byte, why do we even need that bytes keyword? Couldn't we just leave it out? Well, some people like to be very specific so people know. And additionally, there is actually a default setting. So you could change the default to char, and then in this situation, this would be 10 char. And then if you wanted to change it back, you would throw in that byte word. And then you're no longer following the default, and instead you have 10 bytes. You can see how it can be pretty complex. Generally, what I would recommend is just go the extra effort and throw in that keyword regardless, even if it already is the default. For example, let's say the default is byte, but you want it to be in bytes. Throw in the keyword byte, that way there's no confusion. In addition to always throwing the byte, there's another way you could do it, and what that would be is to just change the default and then never use one of these qualifiers. So if you never put something here in any of your create statements, then you know all of your database objects have used the default. The benefit of this, though, is for consistency. If you have some columns using byte length semantics and then others using character length semantics, it's going to be very confusing. Regardless of which one you decide to use, you want to be sure to be consistent. If you want to change the default, go ahead and look up NLS _length _semantics. And then you can learn how to change that and also the downsides of changing that. Now, last question. What values are actually allowed in these parentheses? That's what we are going to be discussing in the next video, so be sure to subscribe, click like, and as always, I'll see you in the next one. Hey, welcome back everyone to your Oracle tutorial series. In this video, we are going to continue our discussion on the char data type. But this video is going to talk about only one small thing, and that is what value is allowed inside of this parentheses. What is the range that is acceptable? Well, the lowest is actually char 1. And this would allow up to 1 byte of data. What about the maximum though? The maximum is actually 2,000. And this would allow up to 2,000 bytes of data. Yeah, I know, that seems pretty simple, but there's a reason I thought it'd be good to separate this into its own video. Because unfortunately, it's not that simple. Yes, these are the values you can use, anywhere from 1 to 2,000, but using these values can introduce new errors. For example, if we declare this as char 1, and we don't specify the keyword char here, it allows only 1 byte. What happens if we try to put an Asian character into that column? Well, we are going to get an error. These kind of problems increase what's known as runtime errors, and these are very bad. So for example, if you're working with a programming language like Java, and you type something incorrectly, you might get what's known as a compiling error. That means we can't even compile the program. But runtime errors is when the compiling works, but the program itself does not work. We get an error when we run the program. And the bad thing about these is that it can happen anywhere. For example, in our code, if we have even one if statement, the path divides into 2. And then if we have, let's say, a switch, it might divide into 5. Same over here. And you can see that all of these endpoints would have to be individually tested for runtime errors. And what that means is runtime errors are very hard to find. For example, in our application, we might only talk to the database at this endpoint. And now we talk to the database and we insert an Asian character into this char 1, and we get an error. So that means part of the time on this case are we going to get an error. If we put an English value, it's going to work, because English characters only use 1 byte. So you can see how finding this thing can be pretty rough. The same thing goes for char 2000. That's because this is 2000 bytes. And if this is 2000 bytes, what happens if we do this? You can see here we're specifying 2000 characters. Well, Oracle was actually going to be okay with this. But in my opinion, this is not okay. That's because with certain encodings such as UTF-8, certain characters can be multiple bytes, and either way, the maximum is still 2000 bytes. So even though we put 2000 characters, if we, for example, put 1001 2-byte characters into a value of this column, that would total 2002 bytes, which would actually break the thing. So just because you can specify char here does not mean we go past the limitation of having only 2000 bytes. And it's just very important that you guys are aware of these limitations so they don't come back and bite you in the butt. That's all I have to say for this video. Hopefully that was helpful. Please be warned on these issues. Always be careful when you're going to the edge cases of the lowest or the highest, because that's when the issues usually start to show up. If you like this video, be sure to click like and subscribe, and I will see you in the next one. Thanks. Hey, welcome back everyone to Caleb the Video Maker 2. This video... I swear my dog dehydrates himself all day just to drink water when I'm recording videos. I swear he does it. This video is going to be covering nchar. Now this data type works very similar to the char data type, so make sure you refresh on that data type. There are some key differences though. This data type is also known as the national character set data type. Whenever you see a data type with something like national in it, this is referring to Unicode. It is highly recommended you go review the videos I created over character sets and UTF-8 and UTF-16 just a few videos ago. That's because they are foundational to understanding the benefit of this column. Additionally, in order to understand why we would benefit from a data type like this, you need to understand how character sets are applied to an Oracle database. So let's say this is an Oracle database, and we have available to us multiple character sets. The thing with Oracle is that these character sets are applied at the database level. That means the entire database gets this character set. This is in contrast to other database management systems where you can often create a character set at the database level, at an individual table level. So if we had an individual table, we could say this is of a certain character set, and even column levels. So we could take this individual column and say this is of a certain character set. Oracle doesn't work the same way. Oracle only has character sets available at the database level. Now there is something available to us that's similar to having a character set at the column level, but slightly different. And that is where the N data types come in. The N data types allow us to store Unicode in a column, even if the database character set is not Unicode. So let's say this is not Unicode. We are allowed to have a table within our not Unicode database that stores Unicode inside of a column. But it's slightly different than actually defining a character set for this column because we're limited to just Unicode. In what situation would something like this be practical? Well, let's say we are working with a database that we know is going to work with applications that use ASCII. ASCII is a character set that uses 1 byte per character. It might be easier for us if everything uses ASCII, including the database. So we might set the database character set to ASCII. But what happens if it comes up where we actually want to store Unicode in our database? If we don't have this data type available to us, we're not able to do that in Oracle without changing the database character set to something like Unicode. Unicode has many more characters available to us and allows for different languages, whereas ASCII limits us to just English. So if 99% of our database is ASCII, we might have 1% that we want to be Unicode. So in order to get this 1%, we can label the column as nchar. Now let's talk about the practicality of this data type. Is this a data type you should be using? That's a different subject. My goal is to introduce you to the different data types. That doesn't necessarily mean they're always useful. Now, I'm not saying you should never use nchar. There might be a good time to use that. But in general, it's almost always recommended to have a Unicode database. And in this situation, the nchar data type becomes a lot less useful, especially since in Unicode, 1 character can also take up 1 byte. That's because, as we mentioned before, Unicode is a superset of ASCII. So this here is Unicode, ASCII is right here. That means if we use ASCII characters inside of a Unicode character set, they are only going to take up 1 byte. So there is not an obvious benefit of making your character set ASCII. Because of that, we are not going to get into the specifics of ASCII character sets. That's because they're not very important to us. The Unicode character sets are important to us. So because of that, in the next video, I'm going to be talking about some specific Unicode character sets that you need to know about. It's not simply called Unicode or ASCII, they have fancy names that you need to know. Of course, nothing can be simple, right? In addition to the end part of this not being super useful because of our database character set being Unicode, a lot of people wonder whether you should use char data types at all. Yeah, you probably wish you knew that before I taught you all about them. But there is some controversy whether you should ever use char data types, and that's something we will talk about in an upcoming video. But essentially, there is not really a huge benefit in using char data types in Oracle. That's all I got for this video, guys. Thank you for watching. If you've enjoyed it, please click like and subscribe to Caleb the Video Maker 2, and that will really help me out. Thanks, guys, and I'll see you in the next one. Hey, what is up, everyone? It's Caleb from Caleb the Video Maker 2. Welcome back to your Oracle series. This video is going to be covering UTF-8 and UTF-16 character sets. Now, I know we already talked about UTF-8 and UTF-16 a couple of videos ago, but this video is going to be talking about character sets that use those encodings. So we, as database people, don't deal so much with encodings as much as we deal with character sets. That's because specific character sets are going to use certain encodings. So the only time we deal with encodings is through character sets. Now, I've mentioned before that UTF-8 and UTF-16 are examples of encodings for the Unicode character set. But it's not quite that simple. We don't just have a character set called Unicode. There are a couple of different options that use UTF-8 or UTF-16. And that is what we are going to be talking about in this video. So we're going to be talking about the very specific names that we need to use in Oracle database. The first character set is AL32 UTF-8. And this uses the UTF-8 encoding. In this character set, each character can take up to 4 bytes. Now, there is another character set, and this is where it gets super confusing, called UTF-8. Of course, it had to name it. And the encoding that this character set uses is UTF-8. So wait, hold up, what is going on here? Well, notice here that this one does not have a hyphen, and this does. So UTF-8 without the hyphen in Oracle is talking about the character set. With the hyphen is talking about the encoding. So here is a good question. If both of these are using the UTF-8 encoding, what could possibly be different between the two? Well, the difference is that UTF-8 is using an older version. An older version of UTF-8, that is. Overall, they work about the same, but the primary difference is how things are stored. Specifically, things known as supplementary characters. Supplementary characters are the characters that take 4 bytes in this character set. The difference with this character set is that each supplementary character takes 2 sets of 3 bytes, totaling 6 bytes. So the way they are stored is slightly different. Overall, it's about the same, but since this one is using an older version, almost always are you going to want to use this character set. This is the default for new databases, and it is the character set you are going to want to use 99.9999999 repeating percent of the time. The next character set we are going to talk about is known as AL16 UTF-16. And this uses the UTF-16 encoding. Now, we discussed this encoding a couple of videos ago, so I'm not going to be redundant and explain that all again. If you want to learn more about the UTF-16 encoding, go watch that video over UTF-8 and UTF-16. There is a fourth character set known as UTF-E. The encoding this one uses is known as UTF-EBCDIC. And this one is super archaic and you're almost never going to want to use this. But I thought I would mention it in case you run across it because there is a chance you might. In general, these are the 2 character sets that you're going to use the most. It's important to understand this character set, and this one when we start talking about nchar, which we are going to discuss a little bit more in the next video, because these character sets are going to come up. This one it might exist, but you can basically pretend that it doesn't. So yeah guys, that's all I got for this video. Hopefully that was helpful. If you've enjoyed this video, be sure to click like and subscribe, as that will really help my channel. Onyx. Hey, what's up everyone? It's Caleb from Caleb the Video Maker 2. Welcome back to your Oracle SQL tutorial series. And I know I'm overdue for a haircut, but you're just gonna have to deal with it for a little while now. So this video is going to be a continuation of the nchar data type. That's because I just had a few more little things that I wanted to explain before we move on to the next data types. The first thing is that when you declare an nchar, for example, nchar 50, this is always going to be talking about characters. That means the char and byte keywords do not apply for this data type. Now we've mentioned that the nchar data type uses Unicode, but remember that Oracle has multiple Unicode character sets. So what character set does nchar use? That is a very good question, and I'm going to answer it. So when you declare a database, you give it a character set and what's known as a national character set. The national character set defines what character set all of the N data types are. But fortunately for me, as the teacher, there's only two options. And those options are AL16, UTF-16, and UTF-8. And I'm talking about the character set, not the encoding. So which one of these do you want to use? Well, I'm actually not going to go in a whole lot of detail with that. That's because if you want to know all of the details, you can go to the Oracle Docs page and find tons of articles on globalization of your software. I will tell you though that this one is the default. And usually the default is the default for a reason. It's because it's the one you're going to want to use most of the time. Now in a previous video, I mentioned that the char and nchar data types are sometimes not recommended for use. Why is that? And the reason is, for example, char, it's actually just stored as a varchar2 with padding. There's not an underlying difference differentiating char from varchar besides the fact that if you make it char, all of the things are going to be the same length. So what I mean is that the varchar column is not going to take up extra space or be slower, and because of that, it's not very beneficial to use the char data types. And the same thing works for the nchar data types. Now I also mentioned that the n data types, so that includes nchar and nvarchar too, are sometimes not recommended. And that's just because some software systems do not work with them quite as well. But a good situation when you would want to use the nchar2 column is if your database is of some character set other than Unicode and you have to store Unicode characters somewhere in your database. In that situation, that's exactly what the nvarchar2 column would be used for. But the char and nchar data types, they are not really recommended or needed for any really good reason. Now before you get mad for me wasting your time teaching about these useless data types, you have to realize that most of this information is foundational for the varchar2 and nvarchar2 data types. So that's really all I got to say about char and nchar. Hopefully the last few videos have been helpful. In the next video we'll be moving on to something new, so thanks guys for sticking with it, and I'll see you in the next video. And as always, please be sure to subscribe and click like. Sup yo, welcome to Caleb the Video Maker 2. This video we are going to be talking about the varchar2 and nvarchar2 data types in Oracle. Now over the last 5 or 6 videos I've discussed a whole lot about the char and nchar data types as well as character sets and encodings. Because of that, I really don't have that much to say. Good for you, right? No, but really, I'm not going to be super redundant and repeat everything I've said. I'm going to share with you the key points just to make sure I don't neglect 2 of the most important data types. But if you want to know the foundation of it all, go back to when I started talking about the char data type. The first thing is the primary difference between the varchar2 data types and the char data types. That difference is that the varchar data types do not pad the data to fit up a certain length. Char data types do. So if you say something like this, every single value in this column is going to take up 10 characters. Even if you only put in 7 or 8 or 9 or 1 or 0, it's going to pad that value to take up 10 characters. And that is a waste of space. Now in other database systems, the way char and varchar data types are stored is different. So the char might be stored one way and varchar might be stored another. For example, in MySQL, varchar takes up extra space because it has to have an extra byte or two to keep track of how long that data is. Oracle doesn't work that way because the char and the varchar2 column data types are stored exactly the same way. The only difference is the padding. And what that means is you should almost never use the char data type and always focus on the varchar2 data type. And the same goes for nvarchar2. You want to use that one rather than nchar. Unless you have an absolutely perfect, beautiful case of why you would want to use char, then you could use it. And in that situation, please leave a comment so I know of a good example. One other difference between the char and the varchar2 data types is the number of bytes it can store. Char is limited to 2,000. Whereas varchar is limited to 4,000. So by using varchar2, you automatically allow for double the storage. Once again, this is bytes, so if you have single byte characters, you can store 4,000 of them. But if you're using Unicode, you want to be careful because if you put in, for example, 3,000 2-byte characters, Oracle is going to bite your head off and not work. By that I mean it's going to throw an error. Now, 4,000 bytes is definitely more than 2,000. In fact, it's double. But 4,000 is still not a whole lot of bytes. If you need to store more than that, you need to look into the large object data types. Hopefully that is something we can get into in an upcoming video. So that's all I got for this video. I know it was short, I didn't have a whole lot to say, but you know, I don't want to be super redundant. So thanks guys for watching. If you like this video, be sure to click like. If you have any other useful tips or notes about these data types, leave a comment. I'll be sure to look at it and consider it, and future videos might say something you had to say. So thanks guys, be sure to click like and subscribe. Welcome back everyone to your Oracle SQL tutorial series. This video we are going to be talking about the number data type. So, what is so stinking special about the number data type? You know what it is? It's that it can store whole numbers and decimal numbers. So it can store integers and real numbers. Both! In one data type. So that means we could store something like 2, or we could store 2.2. I know that doesn't seem like a big deal, but it is. It's really super cool. Oracle attracts my liking because it has fewer data types that are more versatile, rather than some other database management systems that'll have like 4 data types to do the same thing. Now, number can be used to store huge numbers. It can also be used to store very small numbers. And I'm not talking like 1 or 2, I'm talking like 0.00000 whatever, 9 or 5 or whatever. Something smaller than 1. Now the Oracle docs, you can get the specifics on the range of acceptable values, but in general you're not going to have to worry a whole lot about it because this can store pretty big numbers. Now the thing with this is that it's stored in scientific notation. Now the chances are when you learned this in like 3rd grade, you were sleeping. I mean, I was too. I had to relearn all this stuff. So let's do a quick recap. It's essentially a way to express a number using a power of 10. So we could say 2.2 times 10 to the 0. 10 to the 0 evaluates to 1. So 2.2 times 1 equals 2.2. Now you could, theoretically, take this dot and move it. So we could move it this way, or we can move it that way. Generally, it's supposed to be right there, so this is a really crappy example. But let's say we had the number 37. That's a good example. 37 dot. Now, we could take this dot and move it. And that will change the power of 10. So now we have 3.7 times 10 to the 1, which evaluates to 10. So 3.7 times 10 equals 37. You can see we represented the same exact number 2 different ways. Either 37 times 10 to the 0th, or 3.7 times 10 to the 1st. Now, we really don't have to worry a whole lot about the scientific notation part of this. That's all kind of done behind the scenes. So what we need to worry about is significant digits. We could represent this as 7.7 times 10 to the 4th. I had to think about that one pretty hard. And the way we get that is we start here with a decimal. 1, 2, 3, 4, which leaves us right there. And you can see we really only have 2 digits that are important to us, 7 and 7. You could say that these digits are significant. So we really don't care about zeros. I mean, don't take it offensively, 0. I personally care a lot about you, but in general, no one really cares about the zeros because in this situation, they're not considered significant. The actual number of significant digits is our biggest limit. Now the limit from this data type comes from either the significant digits or from the total size. We can only store so many significant digits, and at some point our number is not going to qualify. Or we could just be trying to store a number that is way too stinking huge, like 2.2 times 10 to the 3,000th, or 3001. And in general, that's just way too stinking big. Now, when you declare this data type, you have the option of specifying 2 extra options. So many options. It's like Subway. Oh, that was so cheesy. So we can specify the precision and the scale. And these are defined in parentheses when we give the data type. So something like this. This is the precision, and that's the scale. If you decide to set a precision, you have the options of giving a value 1 through 38. And what this number refers to is the total number of digits in your number. So for example, this number has 1, 2, 3 digits. So we could say that the precision is 3. Scale, on the other hand, is the number of digits after the decimal point. So in this situation, the scale is 2. And note that the precision includes the scale. So the entire number is considered for the precision, but only the number after the decimal point is considered for the scale. So to quiz you a little bit, think about the maximum and the minimum values for something like this. To figure this out, you can subtract the scale from the precision, and that'll give you the number of digits before the decimal. So we're going to have 4. And the biggest numbers would be 9999. And 2 of those are going to be reserved for after the decimal, 99. And also the negative of that, so negative 9999.99. The scale is a little bit interesting because the actual acceptable values for the scale is negative 84 up to 127. And I'll explain how that makes sense of having a negative scale and also having a scale that's bigger than your precision, but that is a topic for another video. The biggest thing to take away from this is that if you're going to specify the precision and scale, the scale affects the size of the biggest number. Because if we have, let's say, a precision of 6, like this example, and we say a scale of 2, well, we are cutting the max size of our number by 2 digits. So if we had 6 for the precision and the scale was 0, we could store this. And this would allow for a much larger number. So if a bigger number is what you want, then you are going to want to keep the scale as low as possible and the precision as high as possible. Because think you can only store up to 38. But if you want a lot of numbers after the decimal point, you can make the scale very big and the precision very big.